Okay, the name of this presentation is called Decoding the Earth, a New Model of Tectonics. It's by me, William Pagano. I am a professional geologist with a master's in geology and a professional engineer with a bachelor in civil engineering. Please watch this presentation on a computer, laptop, or television, anything bigger than a cell phone, and use the highest quality setting. And please have an open mind. Don't worry about what the current model says, and actually what happens is in this model that I present, there's a lot of agreement with the current model, but it's completely different. So you might be asking, how the heck is that? But you have to wait and see. But basically, the current model proves my model. Okay, I'm going to give basically an overview here of the current model and some of its problems as I see it, of course, and really a lot of people acknowledge those problems with the plate tectonic model at this point. In my model, I'm going to show that there's rhyme and reason, consistency, and interrelated elements, which is a really good sign of a good model. And again, as I said, I use the current model to prove my model. So there's consistency even with the current model. But I also have said that it's quite different too. So there's a whole thing going on, but there is a rhyme and reason. There's a driving mechanism, a clear one. And it's really two. I'll discuss that. There's like two plate tectonics or tectonics driving mechanisms. Okay, introduction. As part of this overview, I'd like to discuss current plate tectonics model driving mechanism, which is convection currents. Okay, let me zoom in here. Explanation. Convection currents occur when a reservoir of fluid is heated at the bottom and allowed to cool at the top. Heat causes the fluid to expand, decreasing its density. If there is cooler material on top, it will become more compact and therefore will sink to the bottom. The heated material will rise to the top. So here's a diagram that I always have the source here in all these geologic literature diagrams. So you can see a convection cell here. There's separation at mid-oceanic ridges. There's a pulling apart because the convection cells are such that there's the pulling apart there, you can see. Okay, and to read further on here, inside of the Earth, the mantle is heated by the core. When it rises to the crust, it cools off and begins to sink. This cycle runs continuously and is responsible for tectonic plate activity. The circular motion of the convection cells carries the plates on top of them. So that's like in general, and the claim is that the circular motion of the convection cells, wherever they are, carries the plates on top of them. So that's the main problem that I think not just me, but a lot of people have with tectonics, that these convection cells, these heat currents, are carrying the continents. They're driving the entire mechanism of plate tectonics, which in fact in the literature, yes, does appear random, just like these convection cells. But in my model, I will show that there is a rhyme and reason. There's a specific reason why a given continent will move to a given area at a given time. So anyway, here's the agreement that I have with the current model. I'll just zoom in a little bit. Okay, so there is upwelling at mid-oceanic ridges, which I showed up above. That's just simple physics. Yes, that does happen. Denser oceanic crust will go below less dense continental crust. That's just physics 101. Slab dynamics. Ridge push at oceanic ridges initiates from mantle upwelling and continues from a gravity component. Slab pull at subduction zones is due to gravity. I agree with that if everything's rigid, like if there's one particular slab or plate and one end is pushing up at the oceanic ridge and it's pulling down at a subduction zone due to gravity. So that would only make sense. Disagreement with the current model. As I said, there's no rhyme or reason. Okay, let me just pull this up a little. No rhyme or reason for the driving mechanism of the current model. my model does have very discrete rhyme and reason. Convection currents are not driving the system. The current tectonic system of continental landmass movement is driven by gravity at the center of the Earth, pulling the land masses to damaged crust upper mantle zones in a rotational system regime. So I'll explain why it's rotational, but it finds the path of least resistance, which is through these broken or damaged crust upper mantle zones. I'll get into all this later. Deep plate movement below the continental plate movement appears to be driven by gravity dynamics, even at passive areas where no plates are colliding. So it's all about gravity, not about convection currents. Okay, continuing with the overview, Earth's existing features, which is the center of everything. The existing features demonstrate the modern tectonic regime. It's basically a snapshot in time of a process. Okay, and in my model, we can see these processes, these existing features on Google Earth, in geologic literature and figures, and in drawings. A lot of times the drawings fill in the gaps or whatever to try to show some kind of intermediate process or whatever. So the key to this, it all centers around structures and fractals. I'll define them in a minute. These structures and fractals support both tectonic regime frameworks. There's two tectonic regimes, as I explained, one before the other. And the structures and fractals also demonstrate ductile signatures. So I'll describe what they are now, what all this is. Okay, so continuing with the overview, Earth's existing features. I'm going to go over the definitions now. Okay, so I'm going to skip around a bit because everything's kind of interrelated, as you'll see, as I describe. So typically, a fractal in science is something that's seen on many scales. For example, a rock fracture pattern, a jointing pattern. You can actually see it not only, walking around in the woods on the outcrop scale, you can see it on a microscope scale, and you can see it on a scale like over miles, such as on Google Earth. All right, so in this case, what I'm looking at in this study, and this is something totally novel. I've never seen anybody talk about this or see these things, and I'll describe how to see them, what they are exactly. But these energy fractals represent reaction to energy such as tectonics. So all these fractals are reacting to forces, and they're basically all the fractals are structural representations. So it's like this, it's an unreal world in a sense, but it's real because they're behaving in a real way, but they're not truly structures. They're just showing themselves as structures. All right. So what a structure is something that's relatively stable and formed by deformational forces, often tectonic. An example of a structure in general, and it happens on many levels, of course, not just geology, but the human body is a structure. It is somewhat resistant to additional forces. That's why it's what's left over after such deformational forces. And it has some stability to it because it is intact to some degree. So, if we got hit by a train or something and we would be dismembered, our head would fall off or whatever. It's a horrible thing to say, but we're still relatively stable. Our human body is relatively stable. So what you're seeing are structures because there's a reason they're there. They went through something already and they're what's left over. So whether it's a real structure or a fractal acting as a structure, everything is related to these structures which are left over. Okay, so basically what I was saying before is the energy fractals are a novel science. And in this case, I'm only going to show a few of them in this presentation, but it's what's driving everything, these structures and fractals, again, which are interrelated. So the way I would see these, and I described this in another presentation, but basically they're hieroglyphics in the topography that on Google Earth and all. You can see them, and it's amazing when you do. But you can see them bordered by creeks, vegetation discoloration or any kind of discoloration, lineations, ridges, things like that. And the best way to see them is take a screenshot of Google Earth and then zoom in and out. You'll see different fractals on different levels. Okay, some of them come in like really clear on one level, and then you just don't see them on another. You'll see a lot of examples on that if you really dig into my study and see different fractals on different scales. But these things basically, these energy fractals basically defy science. They sort of have a will or an agenda. And, for example, they go into fault zones. They're kind of searching for heat, in a sense. They're pulled by gravity into the center of the Earth. So I would identify a fault zone because they're either parallel or perpendicular to that fault zone. And the weird thing is if they're small enough or whatever, or if they were formed at a certain time, so that they sort of feel that fault and are attracted to it. And sometimes into discrete sections along the fault. And actually those discrete sections would make sense, such as where there would be a tear or something in the fault because of some tectonic action in the area. It's really, really cool stuff. Okay, and so that's one type of these energy fractals. There's two types. One type is actual geologic events of the continents or structures, which is in the fractal itself is a continent, which is a structure, and they determine the Earth's history. In combination with geologic literature, I can determine what exactly happened and when and why. So it's pieces everything together and it matches geologic literature. Really, really interesting. So I would see my presentation on that where it's very long, but I talk about each step of the way. It's really pieced together and you can determine everything very clearly and specifically, all these geologic events that form the Earth from beginning to end. Okay, and then the other type of energy fractal is one where you see the structure of rodinia, which is an interference refold structure. And it eventually subdivided into the continents after the Canadian asteroid impact, which I discussed in this presentation. So really both types of fractals are interference refold structures because rodinia was comprised of, as per this model, 7 subdivisions, which were the continents, and those continents were generated after the Canadian asteroid impact. Okay, so that's really the principle of fractals because things are subdivided into more of the same. So rodinia, interference refold structure, subdivided into 7 interference refold structures. Okay, so I know this is some weird stuff, but anyway, these structures and fractals show ductile features. Ductile features formed under high energy, high temperature, high pressure conditions. Fractals always show ductile features, whereas structures show ductile and brittle features. There's brittle faults now on our structures, on our continents. So that's the difference. Basically, the reason that there's ductile features on the surface is because at one time they were formed under those conditions of high temperature, high energy, high pressure. And now they've been uplifted as real things with the structures themselves. They've been uplifted and they have brittle and ductile features. And the fractals represent, again, the time that things were high temperature, high energy, high pressure. So it's just a snapshot in time, sort of like a photograph. Very interesting. Now, ductile signatures. A signature is something that shows a complex process or history that is impossible to duplicate or create. So basically, the ductile signatures are seen everywhere. And it's something that I can't just make up, or it's something that I'm not seeing because I want to see it. That can be totally ruled out. Stuff is very complex to duplicate, impossible to duplicate. So if you look at the blue box there, structures contain fractals. Now, our continents are structures, and they contain fractals on all kinds of levels. There's zillions of them. And fractals, which are not real in a sense, they mimic reality. the fractals contain what I call fractal structures. So they basically are structures, and they contain structures within it. You'll see, especially those continent type, those the type of fractal that shows the specific events, geologic events. They are subdivided into, they show many different structures. Okay, so what you see here are features on Google Earth. This is the structure of North America, an interference refold structure, which we'll talk about what the heck that is soon. And you also see I'm going to zoom in later, but you see a fractal of North America at 28 million years ago, more or less, in the lower right. Okay, so this is a structure, North America, showing structural features. Those features have different colored lines that you can see. All right, so these overlaid lines in the different colors that you see on Google Earth are structures and fractals that show ductile features. That's why they're curved and they're bent and they're preserved on the brittle continent, but at one time they were ductile features. All features show signatures which can't be duplicated, imagined, or created. Okay, so there's rhyme and reason here. Why are these shapes as they are? I can discuss this in detail soon. All lines overlaid on Google Earth can easily be seen, although much of them with difficulty. The lines are almost 100% not noticed or addressed in geologic literature. It's amazing. I'm not sure why, but check it out. Why can't other people see these things? These are obvious geology 101 things, some of these features. Some lines features are quite obvious, especially in retrospect. I'm saying visually and all that. You can see some things that are really obvious, like, that I'm surprised nobody talks about in geologic literature. All lines on Google Earth, geologic literature, or drawings are interrelated and consistent, thus giving rhyme and reason for tectonic driving mechanisms. That goes for all lines drawn on my model. All lines drawn on Google Earth, fractals, figures, whatever, they're all related. Okay, so you see here the fractal of North America. This is the fractal type that shows geologic events, high energy events. You see a lot of ductile features and structural features inside the fractal, which is in itself a representation of a structure, the structure of North America, which is an interference refold structure like the other 6. Okay, there's 7 of them total, and they're shown in various fractals. So anyway, we look at these features here, and I'll kind of define things too. There's a Boudin, which was formed on, a Boudin is something that's formed on outside fibers of tension zones. So it's formed in tension zones, and the outside fibers of a tension zone is something that's rotating in a circular motion. So this system is rotating counterclockwise. I know that for various reasons, but one reason is that there's this big SC structure, which is something that's formed from a shearing force. So you can see the shearing here up and down. That's a shearing when they're in opposite directions, and it forms this SC structure. You should see the rotational direction. This Alaska arm here was connected to what is now New Brunswick up here on the East Coast. You have compressional features here on the East Coast. I don't know if you ever noticed, but North Carolina kind of sticks out like that. And when Alaska snapped off of what was where it was connected to New Brunswick, it caused a compression in here, and now it's actually rebounding back up to the northeast because it snapped going down this way, and now it's rebounding back up. Okay, and there's evidence of that I have in this model. So you see a lot of these things, such as these features, such as the confluence of the Ohio and Mississippi rivers. That's the edge of a subdivision of a refold, as you'll see on the main featured North America continent in just a second. But so there's a reason that's there. It's on the border of a subdivision. You can call it a refold structure also, just like North America. So that border is here, and it's defined by those two rivers coming in. You see Big Bend over here where I'm circling. That's a drag fold, it's called, because one side is being dragged down a little faster than the other. So it's kind of an S shape. Okay, so I guess that's it for now. And now let's look at the main Google Earth continent shown here of North America. You see on the outside fibers, you see this thing, which is a Boudin. Greenland is part of a broken up Boudin on the outside fibers here of this rotational system. So you see here, this is New Brunswick now today, and that was connected to, I didn't draw the C in, but this is ready to snap here. It's sticking to the land on this side to another refold, another interference refold structure, just like North America is. So there's 6 others. Like I said, there's 7 total. So it's ready to snap here. One day it's going to slip, and then we're all screwed. We're going to rotate quickly probably. There'll be another high energy event. Okay? Maybe this is why this stuff is not talked about in the literature. I mean, I was kind of kidding. I know the reason why. We don't want anyone to panic. We're in a fragile system right now, and it's going to snap again one day. People knowing this, it's going to affect real estate, and it's going to cause fear, this and that. There's going to be earthquakes everywhere, not just California or whatever they talk about. This whole system is vulnerable, every single continent, everywhere and anywhere. Okay, you see this SC structure. This is the edge of an SC structure in reality. So it was seen in the fractal, and now it's here going on in reality, a little bit more advanced than what's in the fractal, because this is today, and the fractal's 28 million years ago. So I outlined the edge of it there, showing kind of a drag fold, which I said is one side moving down faster. On this side's moving faster than that side down. Systems rotating. There's that drag fold of Big Ben here. The principle of fractals are things are subdivided into subdivisions of other interference refold structures. So you have like a mini subdivision here on the East Coast that's outlined here that I'm showing on the cursor. Okay, and that's where the Boudin squeezed through in the tension zone here, made that. Okay, so again, you see the defined by the outline of the Ohio and Mississippi River here. There's a little drag fold here over by Niagara. There's 2 of them really, because when this snapped off, where it's connected at what is now Alaska area, and right here, it pulled up and then it snapped back down to the southwest and compressed here. So you see the red compressed zone here. North Carolina is at, people know that North Carolina sticks out at a point there. So that's part of this compression zone. You have the rotational signature of the Great Lakes in here, where I'm circling. And Lake Superior is actually a drag fold, because as this dial gauge, so to speak, formed and rotated this way, see the arrow? Because there was an asteroid impact over here, and then it rotated that way, and the dial gauge stopped at this point right here. It hit a front. It can't go anymore. It's it won't last forever. So at least it slowed down here and kind of stuck. So the dial gauge went this way. Okay, and let's see, what else could I talk about? This is in Central America. There's 2 Boudins that were actually within South America. You'll see that later. They snapped out as things were rotating counterclockwise again, and now they're stuck in these positions here right now today. And there's evidence that they were there's different phases here that they went through. So actually, this is for one Boudin here. I only showed 2 of them just to give a general overview. So where the cursor is now was an old sticking place, and now there's the real sticking place right now up against the North America interference refold here. It's stuck. So one day it'll unstick, and there'll be a big problem. Okay. So I think I covered everything. It says here, Boudins, Boudin paths. You can see there's a Boudin path here in Central America. At least it's from one time to another, it moved across here. The Boudin paths are outlined in the dashed lines. Okay. So shearing, differential movement, I talked about that. SC structure, talked about that. Counterclockwise rotation, the whole system's moving that way. Strain buildup, I talked about that. Front blockage, temporary at least, talked about that. Tensional release features and related compressional features. So I talked about that. Okay, and that should cover everything. Okay, I just want to talk about what this is, this Rodinia type energy fractal, an example of where there's a vegetation color change. So these fractals occur in many different, on many different scales in many different areas, all different countries and continents and everything. So here's an example of this vegetation change. I thought this was a mistake or something, some kind of problem on Google Earth. So I'm looking at Google Earth and I see this discoloration in the vegetation. Check it out. It's very, very easy to see. And if this wasn't so blurry and there were some roads there, I could take you to exactly where that change is. But basically, it's like the trees are dead in this area where it's lighter colored, and they're healthier in the darker green. Okay, so you can see some things going on here. Something strange. There's an outline of this this pointed cone or something here, and there's something coming across here. See that? See where the cursor is? Something coming across and something going that way. So this is what you actually have. All right. This is where it is found. That's Minnesota there. You see where the cursor is? And it's near Lake Superior. It's on a fault line that's determined from these Rodinia type energy fractals that go parallel or perpendicular to fault lines, ductile fault lines, and brittle. So here's tons of them. This took weeks to do. You'll see this later too. So that's where it is, and you could see an up close of the what I just zoomed in on in the white circle there. So in that area, this is what you see, and you see there's a nose here. See the cursor? The nose is right there. So that's that nose right there, and this guy in this Rodinia type fractal in yellow is smaller. He's not as big as the red one. The red is the same red one here, going along this major fault line here in this direction. So the yellow one is coming down this way. He might be aimed towards this red fault. See the cursor right there? He might be aimed that way. So there you go. You see the light colored vegetation defines these things clearly. And there's some little ones. Remember I was saying things are on different scales. So these guys have their own agenda in white. They're headed somewhere. And there's another little one in red. He might be following that fault zone too. But anyway, the one in red is clearly following the fault zone. And he's the same. He's the dude right here. You just see this cone over there on the right. Incidentally, you see the one in white here following a fault line here. So that's what it is. It's pretty cool stuff. All right. Thank you. Okay, so this next figure that we're going to be looking at, this is basically it's a figure that I drew as accurately as I can, more or less, to demonstrate something. So we're still looking at Earth's existing features to prove something, to prove some concept or whatever. We have looked at the structure of North America. We looked at a fractal of North America. And now we're looking at a figure of the various, what they're called refold structures on the Earth to demonstrate a point. Okay, so what we have here is the breakup of Pangea in the figure that is drawn about 35 million years ago as the representation here. And the reason for that is it's very similar to today, except that I wanted to show that land has actually, the latest great movements were about 35 million years ago. And what these arrows show is basically the history of movements. Okay? So when you look at this, you can see like a rhyme and reason here. There's this merry-go-round kind of thing going on. I don't have to get into great detail yet, but you also see what you don't hear about in geologic literature in the figure. And check out the cursor. There's a lot of these arms here. There's one there. This became India. it ended up going into an attraction zone here. So there's India. Let's see. I know there's this arm of Alaska, which I talked about, that had snapped off. Africa here, the Africa refold structure, has a huge arm like this. That's the key to this whole system kind of protecting itself. Okay, and there's actually a big arm that you don't see that's connected to the center of the Earth, according to my model, and there's huge evidence of it, and it goes from here down to what is down to this area and connects at the equatorial spin axis. So there's a reason for the equatorial spin axis, and that is sutured down there, and it's under tremendous strain right now. Right now, this arm is actually retracted back. This large arm of Africa is retracted back, and we're even more in like this crazy balancing system. There was a small arm of Africa here that got crushed, formed the Alps and everything, and so that used to be straight up like this, and it got crushed when the big arm grabbed the Russia refold and squashed it in like that. Okay, so there's a lot to talk about here. This is the plates on the right. This is geologic literature, and the plate boundaries are shown. It's a very updated modern model, and so you see the boundaries there, and if you look really carefully without getting into great detail, the movements are highly associated to what you actually see. So the rock breaks differently than how it moves, but it's related. Okay, you could actually see like this outline here. I call this the Southeast Asia refold structure. It's over here. All right, so that's an example. And let's see, what else could I talk about here? Basically, these plates represent an influence zone, so they're going to break on the path of least resistance. They're not necessarily going to break right on the edges of the refolds and all that, because it's a whole system, and it breaks brittly, different than the whole ductile system. The ductile system is shown on the left, brittle system is shown on the right. Okay, something I should note is that basically the current model, in that it doesn't show a dynamic and a rhyme and reason. The reason my model does is because the key to it are these things, these arms, okay? So that describes a whole dynamic. It pieces everything together. Now, even this lost continent right here, that had an arm at one point that I talked about. One of the earlier phases of it, the arm was up here for a reason. It was sort of aiming at that this zone here. I wanted to go in there, and eventually it did. It just took a roundabout way to get there to do it. Okay, but this is showing rhyme and reason, and it's matching geologic literature in a lot of ways, but completely different. And again, if they would have discovered these arms or whatever in geologic literature, there's another one here, just circling them. Another one here. They would see that there's a the key to these microcontinents is really these arms, because Zealandia, microcontinent of Zealandia, was formed by connecting right here a landmass, land bridge, I should say. That continent was here with a nose like this. So as these arms extended, the land bridge formed. There's also a land bridge associated with this little arm of Africa here. That's Greater Adria. That formed up in this way, and then it got crushed. I'll talk about that later, when this arm of Africa grabbed the Russia refolded orange and pulled it in. So anyway, that's the key to the whole thing, and that's what the current model is missing. So I just want to clarify that what you see here, this dynamic, which is it's all about dynamic, not about static kind of things or whatever. So this is defining a dynamic with the arrows. And if you take a look at something I'll show for example, it very much aligns with the geologic literature. So it shows the dynamic here in the key. See this? Types of movement, really. You have a spreading center like the Mid-Atlantic Ridge, which is different from an extension zone. So I'll show you an extension zone. I was just saying that this arm here, this white arm, of Africa, it retracted back a little. I drew the smaller arrows because it's mostly going in the one direction to grasp this orange Russia refold. So it retracted back most recently, and there's like a tearing in here as it retracted back. And if you look, that would be right over here. This red line right here. So what is that red line? It's just one of many examples. That's an extension zone, because as that arm went back, there's a tearing or a pulling here. That's why it's an extension zone. Just an example of more support by the geologic literature. So I'm now going to explain something that's really interesting, very controversial, and that is that our Earth is expanding. So fractals that I found actually pretty much prove that. And even looking at this kind of proves it, because I put in tension zone in blue. So you see that I wrote that in here. All around Africa, which is the center of the system. You see the merry-go-round system going around and coming into a zone that's being stabilized by what's going on with Africa's arm and everything. So all the action is really, there's a lot of tensional things going on, and then there's very localized compression. And it's not true compression, because it's not like the land is shrinking there. It's just going somewhere. It's about the dynamic again. It's not preserved tension and compression zones. The compression is localized and it goes into the earth, and the tension is everywhere. Okay? So if you look at this, I'm going to draw some lines. This actually looks like what's called a triple junction. A triple junction, even in nature, you can see, like when mud dries up, you see like a Y shape. And see, I should put it thicker, but you have this right here. So that's your triple junction, and that's triple junctions are formed in extension zones, or they're extensional features. Okay, so there's your triple junction. All right, and let's take a look at specifically what is going on. For an example, they call it a subduction zone at the Tonga Trench here, what I just circled. So the reason that is a subduction zone is this pulling here, which is really just a rotational thing, if anything tensional, because it's gone from tension to get there. So, and then it gets sucked in, not shrinking sucked in, but just the sections of land like right here have gotten sucked in over here. So it's not a true compressional thing. So there you go. I mean, this is what it's all about. And they call this a subduction zone here because as things went this way, it's still sort of like a lagging behind. There's like this pulling, and that's your compression here. It's like a late effect. So things get sucked in that way, and it's still going. It's like a delayed feature. We're kind of like in a time warp, so to speak. And my model kind of proves that too in other instances. Okay, so let's revisit something again. So I talked about the basically the triple junction feature here. Some of your y is equal, so you got a down component here, down component there. Your x's are equal. So that's why everything's under tension. You see that? It's a pulling apart about that intersection here. Okay? So we know that the system's under tension. And if you were to look at this carefully and you relate it to something in life, it would be like somebody doing a back bridge. Okay? So what that would be the person's head would be here, and the two legs are here, okay, and the main body is here. So just imagine the whole body, the whole system is under tension, and it's like bursting here. Again, this is geologic literature, this blue line. That's under tension as per geologic literature. So it's all centered about Africa, basically. And the centroid of this system Centroid is basically the center of mass. That's in this area, and maybe not so coincidentally, that's where a new ocean is forming, as per geologic literature. So as you have this person doing a back bridge, basically, they're all under tension, and it's like this big circular, not so coincidentally, structure. How about that? The whole big thing is a big structure that describes a system that's under tension. Okay, so there you go. The Earth is expanding. There's evidence of that in my fractals that I find, all kinds of stuff going on. Again, if you look at this, the areas that are even under subduction, I didn't mention the second one. So this is a lost continent here. And this had an arm at one point, by the way, and then it didn't have an arm at this phase right here, but it got sucked into the Mariana Trench over here. And that's another example of, that's not true compression, that's just something going somewhere else. It's pulled in, but the whole system is under tension. It's localized under compression, but not truly compression. It's just going there, okay? It's going into the middle of the Earth. This is the center of action here, where the head is, okay? Okay, I just said something that wasn't really true. This lost continent here that I'm circling, see in the lower right, I call that continent A. Anyway, so this does have an arm. It's not kind of subtle. Right here is the arm. It got flattened out from the actual tectonic dynamic when it pulled out of this area here and went like this. See these arrows here describe all the old actions and all that. So it came up this way, and in the process, it flattened out that foot. So we'll talk more about that later in more detail. Okay, so what we have here is just the United States, the deeper ductile faults that I determined from the behavior of these fractals. As you see here, I was saying they go perpendicular parallel to these faults. So this took weeks to do, and I did one also on the southern part. This also took weeks. So I determined this fault system. San Andreas fault is shown especially in blue. The western fault system shown in yellow. In green, and the central and eastern system shown in black. You can see that subdivision refold on the east coast here, separated in the magenta. Follow my cursor here. The Boudin path that was snapped because between Alaska and New Brunswick, where it snapped that I talked about, it's just like a rubber band. So you see this snapping action signature here, and there's two phases. It sat for a while in the yellow position, then rebounded up to the north in the red position. So you got a little compression here, Texas. So basically the way the rock breaks is related but not the same as the dynamic signature or whatever's going on. Okay, what I got to do is clarify what these red lines are. All the little red lines are brittle faults. This is from geologic literature, and quoted the source here. Okay, so you can see that there's a connection between the ductile features, the ductile faults, which are in green, black, magenta, and red over here on the right, and the yellow, and the San Andreas fault and all that. Those are all related to these features that are in published geologic literature, the brittle sort of shards of glass shattering of the rock. So the rock breaks different but related to the ductile features. Okay, so in a similar manner, I'm showing basically Canada here, and those fractals which are overlaid. You can see them like a little bit faded out there, but they're there. And the fault system is shown, and it's somewhat related to where the earthquakes are, which are shown in the red circles. So the outer fibers of the tension zone, because it's a rotational zone, North America, that's where all the earthquakes are, where there's actual movement of the land, like the drifting of Greenland here, again, which is a Boudin, so it drifted off. And I guess where it ripped off and all is where the earthquakes are. West Coast, we know all about that action over there. A lot going on the West Coast because the North American refold is driving up against a subducting plate. So there's a lot of action going on there. Now, again, is it really a compression area? I just think that the system is really expanding and it's driving up against another plate. It's localized compression, but the whole system's expanding. And there's a lot going on the East Coast too. Kind of around that subdivision that I was talking about. That it snapped over here in New Brunswick area. So that subdivision comes down here, I'm outlining. So a lot of those earthquakes are around the outer area of this rotational zone. Okay, so what we got here is there's those brittle faults marked in red on the left side here, and the published geologic literature on the lower right, those red faults. Okay, I guess just this is more detailed on the right. Shows them extended, longer, or whatever. Different person did the study, different group or whatever. So the ones that I put in, the system in black and blue, are determined from guided by geologic literature, checking out the topography or Google Earth, and finding fractals and also finding these Boudins. I know this all has to do with Boudins because I found several of them. Here's one example of one that I found. Definite Boudin signature there. There's one right here. Probably one here. I found a whole bunch in other states. So I know that this is tied in based on the general characteristics of the Boudins and all. They're following these lines. These lines are probably phases when the earlier ones are to the right. They probably rotated counterclockwise to the left here like I'm showing, right to left. And the final stage connects up, sure enough, to the snapped Boudin thing going on here that I talked about, this rubber band thing that was with the red and the yellow. The yellow was the first of the phases, and it's now rebounding to the northeast. Okay. You can see here some evidence that, well, let me talk about another thing first. See the blue system of faults? As you go from northeast to southwest, you see, at least for similar faults, that they are rotating counterclockwise, which would make sense because the system is rotating counterclockwise. And it's confirmed here. And these are fractals here again, these Rodinia fractals here. They're always going parallel or perpendicular to a fault. So there's a fault here with a little displacement. See that displacement? And the lines matched up, this magenta and this magenta, they were connected. You can see the counterclockwise rotation. Excuse me. Evidence that the refold subdivision on the right, this is New Brunswick, that it actually came up, is that when this rotated off, it would have been blocked by this. So this advanced forward to the northeast, this little subdivision here around New Brunswick, Canada. After that got knocked out counterclockwise here, that piece of land. And again, this was connected on the magenta with the magenta, and the white dashes were connected. So that sliver of land got pushed out in a counterclockwise direction. So, yeah, everything's related. You can't make this stuff up. What can I say? It's all interrelated on every scale. Okay, something else here. See, everything's related, and there's these signatures here that you just can't fake. This is like really amazing stuff. So you look at this, and when something compresses in general, you're going to have like these waves because a line is short and it's going to have like curves in it. So you're going to have, so you got this, then you got that, and then you got this backing up here where the whole thing is like it's called that drag fold again. So I'll write the word drag here. So this is all a compressional signature. So, and I was saying that, if everything's counterclockwise, even the faults are going this way. You got this direction this way and a direction that way, just to make that curve, that kink. So these are older faults here on this side. So it's going in that direction, and as that system rotates this way to the left, it's going to the right over here. Okay, so see how everything adds up. So where's the maximum compression here against this land versus this land? Well, I didn't put the check in the right spot, but this section versus this section, the maximum compression in the area is over here. Okay, So you see how everything flattens out? See the black fault system, it flattens out here because this is the highest compression. And look at this fault here. It looks like it's been highly compressed also. So this one probably formed first in the blue, and then this blue fault got compressed over time as the system was rotating counterclockwise. So I mean, all these things, even if you don't really understand what I'm saying, you can see that this whole system is interrelated, and you just can't fake this stuff. So this is a typical example of how I really know what I'm talking about, and you got to take this seriously. Thank you. Okay, what we have here is a North America refold structure. We talked about the internal features before. You could see everything's based on rotation. All those lines and things that are going on are in a rotational system. There's internal rotation and there's rotation as a unit. In fact, everything's grinding up against that, see where the cursor is, that San Andreas fault there. So they're calling that a compression region, and really it's just the rotational and tensional system butting up against another plate here and causing localized compression. Okay, so this model is very fractal supported, and you'll see a beautiful fractal here of the breakup of Pangaea. This is in Maine like 110 million years ago is what it represents. And there's actually an asteroid impact fractal here. So it's hard to see on this scale, but it's there, and there's several others I found. And there's also a Great Lakes fractal here. I see that a bunch of times too. That's not visible here, the detail of it, but it's documented in the model. So these fractals are totally amazing. I mean, look at the Russia refold here. That was stacked up on top of the North America refold when everything was intact before the asteroid impact. Everything was Rodinia, the supercontinent, and it was subdivided into the what are now the continents, these structures, and they separated from all this action from the asteroid that hit. So check out the this fractal here. Look at the Russia refold. It's like falling off a cliff off the back of the North America refold. You can see the it's holding on to dear life here. You can see it's trying to stick to it. It's all flat in the front on the headwind section. It's all flat because it's going in that direction. See the blue arrow? The tailwind section, so to speak, has that tail going back a little bit like that. And so this is Africa here. There's the little arm of Africa. Here's the big arm of Africa right here, ready to snatch that Russia refold. So these fractals, like I said, they describe every little high energy event, and there's several of them. And here's another one. So you could see that North America here was crescent moon shaped, just like the other 6 of them, 7 continents or subdivisions of Rodinia, the superstructure. So there's that another impact fractal, asteroid impact fractal there, and what now is Canada. So anyway, you can see at this point the leg of North America is kicking up and it's ready to flip over, and eventually it's going to look like this, which is unrecognizable. Okay, so yeah, all the makes sense, right? That all the refolds looked similar. They're all stacked up against each other, just like Africa and South America were attached in a similar manner. So I keep mentioning the word, the 2 words refold structure or interference refold structure. So this is pretty heavy stuff, but basically it is what it sounds like. Something's folded and then refolded, and it's a structure. There's an interference pattern that causes a certain characteristic of the interference refold structure. So anyway, that's what I know, I could say, the 7 continents are, the 7 original continents, which have become busted up and moved around and this and that. So what I want to show you and what you should understand is that when these refold structures formed, they had to have been in like a big, huge area, like a huge system. You think of like wrinkles on your clothes or whatever. For each wrinkle, that could be a structure like Rodinia, or like 7 of them in a row. There's Rodinia, And there's a whole system of them that should like dissipate on all areas on each. When you go around the system, they should dissipate to nothing. And the center of it, the heart of it, should be like the most action, the most refolding, so to speak, the most things that actually made the structures in the heart of it. And then where there's nothing going on, it slowly dissipates to nothing. So it's got to be formed in a big area. So if we look at this here, this is a textbook. There's the source. The refolding, I'm saying that it's formed from an impact. That's the only thing that could do it. And the conditions were just right. According to geologic literature, the crust was thin and everything, so it's able to form a tight fold like this. So as the land was formed, folded as such in the first event 2.5 billion years ago, probably on another planet. Yes, I know it's weird, but that's the deal, because it has to be. These gigantic structures did not originate on Earth. All right? And then there's another event on that large planet or whatever it is. Maybe it's the sun. The sun is still on fire. Who knows? So there's the second event about 1.3 billion years ago. And I said it's an impact then because that's what can cause this also, this refolding. So when you add the two compressions together, it'll make an interference refold structure, which you see in the yellow. And that's like what Rodinia looked like. It's got the two legs and the cone. And that's why you see those types of fractals as such with a cone and two legs. They look almost human. Very bizarre. And they're all over the place. Every level, tons of them in these, everywhere on different scales and everywhere in the world. So there's your crescent moon. These are like, actually Rodinia subdivided into this. And, you know, the principle of fractals for anything you're talking about, fractals is like the parts similar to the whole, like things get bigger on different scales. So this thing in yellow could be subdivided into the things in blue, which they are according to my model. And with these refold structures, you can see the profile in red. There's a closed end and an open end. Here's the closed end where the cursor is right here. So that's this part of the refold structure. This is all closed end right here where the cursor is. Okay, so if we go back to this, basically there's a system here. I keep talking about a system that's in counterclockwise motion basically, and there's an equilibrium going on. In science, everything is about trying to reach equilibrium. So the system is trying to reach equilibrium by going in a counterclockwise direction. And that was caused from the disruption. Everything was stable. It was disrupted from that asteroid that hit in Canada. That's denied by geologists. Like, no, it just looks like an asteroid impact, but it's not. It is. So that disrupted the equilibrium. And it's trying to reach equilibrium now. The whole system's in like this crazy balance and things are still moving. In some areas are moving and some are like in the delicate balance. But right now is the reaction and restabilization phase basically. Okay, so that's, on the large scale, that's what's going on right now. And to clarify, this is your reaction and restabilization phase. So the arrows are the history of all the actions, okay, and the relative sizes of the arrows are the relative size of the action and all that. So everything's trying to stabilize, as I explained. It's still moving, it's still going on. We're sort of living in a time warp. So it's in the delicate balance, especially now that this arm here, see where I am? Where this has moved back to this area. So you'll see a figure of that later. But yeah, we're in a definite delicate balance, and I think this is something that the authorities don't want you to know about. Okay, what we're going to talk about now is basically, again, how the model aligns with the published geologic literature. In this case, tomography data, which is shown as the figures on the top, the one figure on the top. There'll be other ones, but we'll look at this one for now. And there's a whole dynamic here that's seen with this. They say a picture's worth 1,000 words or whatever. So you're going to see what's going on here. See how, again, the refold is flipped on its back, as you see from the fractal. It's flipped over. There it is, flipping over again in another fractal. Okay? So what that means is we're looking at a profile here on the top. Okay? What's that black line? That's where the suture is, where everything sutured together. So that would be like right here or right here. You know, it came together there. This eventually closed here. All right. So sure enough, the structure, which I drew out in red here as the bottom of it, and I drew it in the white here. So sure enough, your closed end is going to be here, and your closed end is here. Because here's the closed end. So you still have on the East Coast a closed end over here. This is like Florida here. So your closed end is right there. And your open end, where it's thicker, is over here. And your open end, which is, this is going to join it over here. So this is your open end also. It's going to join your other open end here. So that's why your two thick areas are here and here. Your open end, your two thin areas are here and here. So that's how we can confirm the structure there, the structure of the structure, so to speak. Okay? And if you look at this tomography, the redder colors are less dense, and well, that's what it means basically. And the purpler colors are more dense. Okay? So it looks like you have your redder colors where all the action is, where there's molten things, which makes sense because the molten rock is less dense than the other rock. Excuse me. So, boy, I battle allergies. Okay. So there's your less dense area there. And what could this be, this purple stuff here? Could it be that the refold structure actually went on top of an old oceanic plate here and here, which is now dropping off from gravity? So where it steepens, it suddenly drops off. There's a slope break here. So where there's a slope break, it suddenly says, I'm going to go, and I'm taking you with me. Look at the look how the similar structure of the ocean plate is versus, which is this here where I'm highlighting, where the cursor is, I should say, and where the red line is. It's the same exact shape. So it's peeling off, and it means that the North America refold structure likely skated on top of something denser, which is the oceanic plate or whatever. So when this plate came down, see the yellow arrows? It filled back in. See this yellow arrow here? The material migrated in after the slab sunk. So that's really what is going on. And where the slope is suddenly going steeper is where it destabilizes faster due to gravity. Everything's based on gravity, not convection currents. So you see everything sliding off from the initial shape here to the same shape, but it's pulled off and it's rotating down, it's sinking. Okay? And actually, even on the plate itself right here, it looks like it's destabilizing at a slope break again. Slope break right here. There's a slope break. So right at the slope break, basically, it destabilizes there. And right at the slope break here, looks like it's starting to destabilize there because that's why you got this going on right here. All right, so slope break here, destabilizing. And if you look at here, your less dense is your red because there's a lot of action in here, a lot of molten material. And you got this slope break here. It comes down, so it's going to suddenly drop down there. The old oceanic plate or whatever is going to drop down there. You have another slope break here. So it looks like there's something going on here where it's less dense here, probably due to the slope break. And you got, it just can't handle that slope here, so it's going goodbye there. It doesn't bond to anything here, so that's why it's slipping down there. It doesn't, it's stuck here. and then it just doesn't bond there, so it's falling off. It's just too steep, it can't handle it. So there it goes. So that explains this slope break and molten material and all, so it just can't handle that little slope break there. It goes down the oceanic plate, and it's steady here, and it's starting to get steeper here, so it's starting to destabilize here. You see in the red, and then it just drops off finally here over there. Okay, let's read the text boxes. Less dense zones are at the most active gravity-driven zones, such as at slope breaks of the slabs. So there's your locations there. Material migrated in after the slab sunk. So, this was here, went down, something's got to replace it. There it goes in. Okay. And let's read this quickly. It appears that the entire continent structure of North America had slid above the denser oceanic crust that stuck to the continental crust. The oceanic crust is actively breaking off and sinking. The dynamic of the denser plate movement appears to be driven by gravity. The areas of greatest movement by gravity are adjacent to least dense areas, suggesting that when possible, the dense plates move through the paths of least resistance, which are the discrete zones that are less dense. It also suggests that movement of the denser plate created these less dense adjacent zones. These zones may be at slope breaks in the plates where the plates can flow downward by gravity more easily. All right. So we discussed these here, and what we have here is this is in New York State. You can see a profile of the refold structure, the closed end right here. Okay, and I think there's a little bit of a curve to it. It's hard to tell in this diagram, but that's what you'll see some of the refold structures have, as a slight curve to it. Decoding the Earth, a new model of tectonics. So now, after discussing the features of Google Earth and the structures that are there and how everything's interrelated, we're just going to look at some internal structures and features that are further evidence of the consistency of the model. Internal structures and features are consistent. Okay, what we've got here is internal features and structures on North America, on the North America refold. So again, I was saying the refold structures contain internal structures, everything's structures, and fractals too, which are structures, like an imitation of structures, and they have internal structures. So everything's all related. Okay, so Boudins are formed in a tensional system, like I was saying. So if that asteroid hit here, see the cursor, and then it pulled everything this way and made that dial gauge kind of signature, you could actually see like the beginning path here, which ended up closing up here where the asteroid impact came. It's actually over here, and then it kind of drifted this way because everything's pulling that way. So it made that scar here, which closed up and then eventually rotated that way. And you have the current scar, which is stopped on a front. At least for now, it's stopped here. Okay, so the tension side, which is going to pull, are going to be where these Boudins are, which are in yellow, the structures in yellow. There's a chance that these are not real structures, that they're actually fractals. They kind of have a cartoonish look to them. So this whole thing's very weird. I keep thinking about it and thinking. I don't know if they're real structures. I'm assuming they are. Okay. But there they are in yellow. And I put a pathway in. There's two pathways, one in green and one in red. And they join up. This big guy kind of gets lost in the path. He goes through a different system down further here. He ends up going off the page into the south part. But these ones together that are close to the asteroid impact are following the paths, and they join up, and then they go around like that. So where there's compression is where there's folding. So I believe these are structures too. In the red folds are like the center line of the fold. So here they are. There's another one in blue right here. Okay, and here's one right here. Here's another. These were actually together. Here's more evidence that there's that rotation this way, because this shows a signature that these two were together. See, I'm circling here and here. They snapped off and one went that way. And why are these under compression? Because the asteroid impact came this way and compressed it. It was all here. Now they went that way, but it was all here and it compressed it. And everything's moving that way, so it's making compression here. There's a whole zillion of them that I didn't show. These are just the to show like a principle and all that. So they're just showing these three here, and this one was below, like I said. So that's what's going on. The internal structures of North America, which are Boudins, folds, and even the SC structure, which is, there's a big one right here in blue. See this outline in blue? That's a big SC structure showing shearing, greater force on this side than this side, but it's all going that way. And here's an SC structure too, by the way. This side went faster down, see the arrow here, than that side. It's basically, I mean, nothing's going up here. It's just that it's going down more that way. So that's why it made that SC structure. Okay, so you have those structures, and they're consistent with a rotational regime. Again, there's tension on the west side and all with the Boudins, compression on the east side and the south side, including below with the impact. There's a distinct flow path, like I explained. Boudins are pulled into zones. Now another thing here you can see is the continent is kind of shedding. So Greenland, again, is a Boudin. See on the upper right here where I'm circling? That's Greenland that got kind of shed off and pushed to the north and east. So things are getting kind of pulled into the flow, which is there's less resistance and higher flow sort of that are out into the ocean off the mainland. There's nothing that's going to stick to it as on the mainland. It wants to be free and able to flow and get sucked into those zones like those other continents that I described before already did. You know, everything wants to be free from the mainland, so they tend to drift up. That's what's going on. That's that shedding or continental drift. So again, the asteroid impact, which occurred over here, and Earth expansion is pretty much laughed at. Like mainstream science thinks it's a bunch of bull. But I'm really showing it here, and I can talk for hours about it, but I won't. And the model mechanics are related to the current model. So it's just really consistent in a lot of ways. You start to see how the model that I have is very different yet very similar and agrees with the current model. Okay, I didn't mention a certain structure over here. So if you look at Southeast Canada here, first of all, this fractal in yellow right here. See that outline in yellow? It's a Rodinia fractal. It's very recognizable, I believe, by anybody. That was the first fractal I saw, and I've since discovered like probably hundreds of them. This is really, really interesting. If you could see it, it'll freak you out. Very, very clear. So check it out. You can see it on most scales. Just check out Google Earth sometime. Check out this guy in yellow. So you see that structure in maroon right here. This is an SC structure where the force is greater on this side than this side. So it's pulling in that direction. It's being sheared. So there's actually a fold in blue here that I mentioned before. See this fold in blue? And that gets pulled along the direction of the shearing. So it actually, you got this compressed structure here, this fold, and then it's pulled here. So you see that it's actually, you know, it's working hand in hand with the structures. So I believe, yeah, this structure is in fact a structure in magenta, and the blue is actually a structure too because they're working together. They verify each other, so to speak. Okay, and this is a fractal here. All the weird stuff is fractals. This little guy in blue. Okay, he's like traveling on the back of this other fractal, and he's heading in this direction of the blue arrow right here. He's going that way, and the headwinds are bending up the nose and everything. So just interesting, really interesting stuff. Okay, what we see here is geologic literature maps of the area of the asteroid impact. And look at the one on the left. I drew in that red arrow. That's the dial gauge kind of movement of due to the rotation about the asteroid impact area. And what these teeth mean, see where the cursor is, they point to the side that's been upthrown. So it makes sense that if it's rotating this way, kind of like a bulldozer, like literally the stuff that's on top was pushed on top. As it goes that way, it's kind of pushed on top of what's below, which is over here. So the stuff pushed on top is the left side. And as you look in the right diagram, where the cursor is now, even the formations and all, you can see clearly signature here about that same size and shape and everything. That's Mesozoic, Cenozoic rocks. There's mineral deposits associated. You'll see gold has got a strong correlation to the asteroid impact. So this formation is kind of duplicated over here in the brown. And yeah, it's tectonics, but what's the cause of tectonics? Tectonics are the direct result of the Canadian asteroid impact, as per my model. All right, so what we see here is the Great Lakes rotational signature. It is another example of internal structures and features that are consistent. This is related to the impact feature that we just saw in the previous slide. And the Great Lakes rotational signature is below that dial gauge region, and it's where it should be. It's within the arc of that dial gauge. Okay. So what you see here, I'm going to look at these features that we see on the Earth today. So here they are. Okay. See the cursor here? So when this arm over here, this is where at New Brunswick, Canada, and what is now Alaska area got snapped. So it came down, and it's called a drag fold as it kind of stuck and compressed in this area. So that's a drag fold. This is also a drag fold here, and that's from that dial gauge action. It dragged this faster than here. Okay, so maybe this has yet to unstick sort of and pull it straight, but for whatever reason this was dragging faster over here than this part right here, so it caused the drag fold. You see there's this pivot point. All these lines that I drew in are different phases of rotation. So the boundaries of these lines are all, I guess you call them lineations, edges of lakes and things like that. So there's multiple phases, and they all come together at this pivot point. So that's kind of interesting. So it looks like these circles that I drew in, they propagate to the east-northeast through this zone here. And looks like they got squeezed also, which would happen because you have a narrower zone here up in the headwind, so to speak, in this direction. Okay, so now we'll look at what I did here is I overlaid these lines that I was just talking about on current Google Earth figure here. So I overlaid the lines, and I saw that there was a fractal here. So this fractal is result of really many high energy events and all. Shows a history, and it actually looks like there's a future trend here. The dotted line in white looks like it could be a future trend because the last lake, I guess, is this one over here in the purple magenta in the insert on the right. This purple line here is pretty much the last lake that we have today. But if it continues propagating, that's why I say it's like the future. There'll be like another lake or whatever, another kind of lineation of some sort. All right, and actually, it's interesting because if you look at where this was encountered, it's up in the headwinds from the actual lake, or the rotational signature, whatever you want to call it. There's several lakes forming a rotational signature, so it's up in the headwinds, almost like it is the future. So that's why you have like a future trend right here in the white. Okay. So I mentioned the pivot point, the drag folds and rotational lines being overlaid. It works out perfectly. So if you look at where these lines are, it actually forms a lot of lineations. It matches up beautifully onto the current features on the Earth, but this is really a fractal, so there's that consistency there. Okay, so basically it's also confirmed by these shear sense structures, they're called. So there's a lot going on here. There's like this flow going on, and there's this differential forces really cause, or would cause, the drag fold, sure enough, in blue. Okay, so it's a little complicated, but that makes complete sense. So there's structures that are consistent with fractals, real structures consistent with fractals, and this fractal is basically an expression of, or feature in, a large structure. which would be North America. And you'll see, well, if you really looked into my model, there's several examples, different time periods when there's fractals of the Great Lakes rotational signature. So it's always consistent with these fractals, especially the ones that show North America, and then you zero in on a section of that North America fractal and you'll find a Great Lakes signature. So this one in particular, I don't know where I didn't find the entire North America structure associated with this, but regardless, it's still where it should be. Everything checks out. Okay, what we have here is a fractal of the Great Lakes rotational signature in blue right here. And what I've outlined in blue is exactly what there is today, okay, with the lakes. And even the peninsula, look at see the cursor? The Michigan Peninsula. Looks like a glove. So there it is, right there. And actually, I mean, this isn't an exact science or whatever, but you could almost see another lineation today of Lake Michigan here. So in a sense, it's even closer to what you see on the fractal. Okay, but relative size-wise and relative shapes and everything, it matches up perfectly. So I put the lakes over here. That's just what you have today. And in this fractal, there's actually a lineation that is a result of the drag fold from the dial gauge from the asteroid impact, which is above to the north and northwest. Okay, so this fractal is found where it would be in a North America fractal of a high energy event. This was like it's kind of a range of time between 74 to 36 million years ago in Maine, USA. So there's this heavy compression going on in here. You see this compression? See where my cursor is here? There's compression there. And I guess not long ago, this arm here, which is now near Alaska, had been attached at New Brunswick, and it snapped back, and things are in the process of really compressing. Okay, so there's a lot of consistency here in, again, the fact that things match up to reality, what we have today in the fractal. And obviously the fractal is, things haven't changed much in regards to the Great Lakes signature from this time period, because the features are basically the same. Okay, and amazing stuff here. There's lots of these Great Lakes fractals, like I said. Okay, what we have here is tomographic data, existing geologic literature. I put in these black line here and these lines here for the profile. These are profiles here, section A1, A2, A3 from northeast to southwest. Okay, and that suture in black is shown. So remember that at the suture, the open end of the refold where it's thicker is shown. So you see the cursor here. It's going to be thicker there on each side of the suture contact. And your closed end are going to be on the coasts here. Okay, these lines here, the red on the east coast is the bottom border of the refold structure, and it's in blue on the west side of the suture. Okay, so you'll notice that from northeast to southwest, that suture line is rotating counterclockwise. And that does make sense because if you look at this up close, it's concave to the left or to the west, and that means it's pushing out to the west. So sure enough, that's what you see in the cross sections. And then you'll see this crotch here to the north, and that is now rotating. You can see it's rotating counterclockwise to the it's bulging out now concave to the east, which is the opposite. So it's obvious that your system showing a signature of rotation counterclockwise about the impact. All right, and just to show consistency that I put in these borders correctly with my structures. You see the closed end on the coasts. It's fully shown basically in A1, goes all the way coast to coast. Now you go to A2 on the west coast, it doesn't quite go all the way. So sure enough, you see this doesn't go all the way. So just trying to prove that I drew these lines incorrectly. So basically, what you're seeing is consistency with the published geologic literature. My model is showing alignment with it. Okay, so we're showing internal structures of North America again, how they're consistent, showing what happened, showing the dynamic, and everything's based upon counterclockwise rotation and all. Some of this we discussed. What I want to talk about is to further show the validity of my results, how things are mimicked. Now, if you look at, this is the East Coast subdivision of the North America refold, and you can see that snapped rubber band kind of thing going on that I talked about, where the Boudin pathway snapped like a rubber band, so it shows that signature. Went from the yellow to the reds, rebounding now to the northeast. So if you look at the actual rubber band structure or whatever, you can see the borders. See where the cursor is now? The border kind of mimics the internal structure. So, okay, so the East Coast is an internal structure, but the internal structure of the internal structure is mimicking it in a sense. So you have your bulging area here where there's compression. See where the cursor is? It's all folded up there, and it's a little wider there to make room for that. And then the two paths, the red and the blue and the red, kind of mimic each other, more or less. Okay. So you see here, see this blue line where the cursor is? That's kind of sort of what's going on here. Okay. So just trying to prove things are good. We talked about this drawing before, counterclockwise rotation. This one's very similar. It's actually a lot missing in this that is in the drawings for the model, but you still get the gist of it here. Things are rotating counterclockwise, and land's pushing off or shedding out due to this rotation. Okay, so again, everything's related. The North American internal structures are related to the rotation, counterclockwise rotation. The Boudin path borders mimic the refold subdivision on tensional outer fibers, which is where where those Boudins formed and the Boudin path snapped. There was the outer fibers of the large North America refold. Okay, here's something. There's what's called a drag fold here for an outcrop in New York State. So there's like a white quartz layer here, and there's basically a drag fold. Now, where that was found in a mapped out, which is in black, a mapped out refold subdivision structure in the area. So that outcrop is right over here, which is where it would be, because if you look at where it's found in this refold and outlined in blue, it's found in this area, this drag fold. Drag fold meaning it got, when that rubber band snapped, so to speak, it got dragged down as such, like faster on the left side. So you see it drag down more on the left side versus the right side. That's why it's making the S. So that's found over here, which is where it should be, because if you look at where it's found actually on in North America, it's found here, which kind of mimics each other here, where it's found on the mapped section in New York State. Here's New York. Where that was found was like right over here, but in the structure it was found over here, which is exactly where it should be found. Hope I'm explaining myself well. This is a very hard thing to explain in general, this whole entire project. So there's outcrop support from New York State, and it's consistent in form and location along the drag fold, as I explained. There's that continent shedding, so to speak, with that continental drift. Everything is showing a rhyme and reason, and there's that rotational thing going on everywhere, and the whole large structure is also rotating. So see, on different scales, everything's rotating and everything's consistent. Okay, what we have here is basically southeast North America, southeast United States. And there's these huge structures that I found. We have an SC structure over here, and outlined in yellow. So you can see it, shear direction is shown by the arrows, so that's why it formed the structure as such. And there's two more of them here, in Tennessee. The direction of movement is shown. Okay, so what's going on here is these internal structures are consistent with what happened with the whole dynamic. So you see this one here that I'm circling. It is shown in detail here with what happened. This snapped rubber band again in red. So you see how it came down, what I call the drag fold. This part was dragged a little faster than over here. So it dragged it down. You can see the yellow arrow, that's consistent. And in doing that, it kind of compressed and like pushed up here. So you see that yellow arrow is consistent with the whole form of the red rubber band snapping, so to speak. And we talked about this before, so that's the whole regional area, snapped rubber band thing going on. All right, so published geologic literature. This SC structure is an active area. These are fault hazard maps, which are the red areas are the hot zones. So that structure right here in Oklahoma is right here. This is basically the New Madrid fault area, where where I'm showing here in blue above. See that where I'm circling? That's where that comes down. The Ohio and Ohio River over here, Mississippi River there. They come together over here, and that's like a hot spot there. And then these two structures here, at least one of them, let's see. Doesn't really matter which one it is, but that's causing this hot spot pretty much. Okay, and this I'll talk about later. That's a reason for that one there. So again, there's the SC structure. All these SC structures confirm internal dynamics and they're related to the rotational regime, and it confirms actual published data, and where the brittle breaking of the rock mass, which is shown in the hot spots and all, where the earthquakes are consistent with the ductile dynamic going on, the ductile regime, the whole thing. Okay, so more consistency. Okay, we're just looking at a close-up now. This is those SC structures in eastern Tennessee, and we're looking at another published geologic data figure here. There's eastern Tennessee, sure enough. Lots of dots for earthquake density. It's a hot spot. So that's right where these are. And let's take a look at something here. This is the basically the rubber band thing that I was talking about here. See the red rubber band? At one time yellow, it moved up. So the red one is pretty wide band of sort of like a fault zone. And that's the folded Appalachians, by the way. So they come down like this, and see where the cursor is? So they get thinner on this side, and they're thicker on this side. Well, okay, let's look at this structure. It's remember I said the rubber band, so to speak, is rebounding. So there's your rebound on this arrow in white here. So it's rebounding up. What would happen if it's rebounding up? It's moving. So this would be flat in the headward wind direction, so to speak. It flattened out that structure right here. And again, so it's rebounding, so that's why it's shaped as such. And your I went over this before, but your forces from the snapped rubber band makes that yellow arrow that way. And your SC structure in white, everything's consistent here. These are like mirror images of each other. You see the the shear direction is the opposite. This is counterclockwise and this is clockwise, but they're both SC structures and they're consistent. They complement each other because you just see the arrows and everything. It just does. Okay, so that's and again, if it's thinner here and thicker here, that makes sense that that's flattening and it's pushing up a zone, or it's going up into the headwinds and it's flattening out, and now you got a wider fault zone here. Okay, so it's thinner here, thicker here. See that? You can kind of tell by the colors here. Thicker here, thinner here. So it's consistency again. All right, just to clarify something here, as this system is rebounding to the north, that red mobile fault line is rebounding to the north. What's going to happen is, okay, so it's going this way. What's going to happen is, of course, it's going to be thicker over here than over here, because as it's flattening here, that means there's material kind of coming in and thickening up. You see how that would happen? So it's like you're resisting motion a little bit, and it's going to force this to flatten out and accumulate here. So it's just going to be generally thicker to the north. Okay, what we have here is another SC structure, and this is also related to the action of the snapped rubber band, most likely, because you see that downward action of the rubber band that snapped, it came down and pulled everything down. So that's why it's shaped as such, with this counterclockwise shear direction. Follow the white arrows. So that's why that structure is there. And apparently these structures cause earthquakes and all. It's a little blurry, but you can see the red dots in there. That's like a kind of a hot spot for earthquakes and all. So that's yet another area I've described that has structures that's geologically active. Okay, so there's consistency with the geologic literature, which is in this figure in the inset, and my model, which is shown in the main figure here. All right, just to clarify something again. Now, I stated that this rubber band thing has rebounded to the northeast. It was on the yellow, see this diagram here, went from the yellow rubber band, so to speak, to the red, and it's rebounding to the northeast. So even if that's true and there's now a force going this way, the original force that formed this SC structure was with a bigger force going in this direction and caused this area to bulge here. So that's why you have the shape of the SC structure from this, essentially, the original one. But even if it's coming back, perhaps this used to be worse, where it was like this before, for example, and now it's rebounded back to what you see in yellow. So you might be saying, okay, I thought it was rebounding. You're just telling me that it's rebounding to the northeast. Yeah, if it is, then this structure here in yellow is just being modified to less severe from the red here, from the red to the yellow. That could be possible too. Actually, it's very likely. Okay, yet another thing to confirm the consistency and accuracy of my model. There's published geologic literature here in the center, this BFZ, which is a fault zone in the heart of Texas. And here's the Texas border here, Oklahoma. There's Texas. So you see this blue line, which is the border of that subdivision refold on the East Coast. So that, is a structure itself, and it's rubbing and grinding. So see where it comes in, just on the north end of Texas here is the Texas border. So that's coming in. It's not shown here. So again, where the rock breaks versus the ductile fault or whatever may not show up as a fault on the surface as it does here, because we're talking about this area. But this is where it takes a turn. So it's fault zone goes like this. It turns here, and that's what we're looking at over here. So that's what, and actually this comes down and it bulges out. There's like a belly here, it bulges out. It's not shown here, but well, actually it's shown over here. So there's Texas. It comes down. There's that belly that comes out. Okay, see that? And that's where this is, this belly that comes out here. It'll keep going, but point is, again, even the borders of the refold structures or subdivisions or whatever are active tectonic zones, as in the case here. And the shape of the fault or fault zone often mimics what's causing it and all. I know the brittle surface is going to break different than this, but sometimes it's pretty similar, as in this case. Okay, what we have here is there's clusters of gold deposits in the United States. You see you got a little one here, these ones here. You got a pretty big one here on the East Coast, southeast. You got one here. You got one here. And you got several of them all over the place that are a little hard to see, but they're all encompassed inside this gigantic SC structure. So the fault system is shown. The San Andreas fault is in blue here, and there's a green fault system over here that I drew in. That's the faults that I determined. The published geologic brittle faults, published geologic data is in red. So even those faults are like clustered within that SC structure. So remember I was saying the structures tend to give a lot of faults, a lot of active regions are associated with these structures, as you just saw. So you could even see this down drag on the left side more than the right side. You can see the blue arrows is kind of the flow direction. So even the fault system, see where my cursor is, it's kind of being dragged down. There's that signature of being pulled down even in the fault system. And basically, again, the geologic data is confirming my model. This massive SC structure is related to the rotational regime, and it's confirming the internal dynamics of the structure, the North America structure again. It shows how rock mass breaks different. Those red brittle faults are different than the other faults, but related, that I drew like in green, for example. So everything's all related. These gold deposits, as you'll see, are all related. They're there for a reason. There's distinct areas here for a reason, and the big one, of course, on the west coast. So basically the 5 zones are the west coast with the SC structure. The Midwest, there's an asteroid that, the asteroid that I was talking about, this is directly associated with that. This is with association with this thing called the Mid-Continent Ridge structure. It's a miniature refold structure, and that's like trapped in a zone within the northern reaches of that. And the southeast is this is associated with the snapped rubber band thing again, okay? And the northeast is associated with Boudin paths that you saw on the other slide. Okay, so everything's all related again. And here we go again and again, but I'm going through it, and some people are going to start really taking this seriously. Okay, so here we are with those 5 zones again. Now you can see in this figure on the top more clearly the different types of gold deposits. Okay, so they're all encompassed within that black outlined SC structure. All right, there's our fractal friend over here. There's that SC structure that I found there at an earlier stage, a little less rotation with it. It's not as compactly developed as it is here today, but there it is, clearly that SC structure. Okay, so let's continue on. Okay, what we have here is there's a particular gold deposit, really 2 of them, and they're associated directly with the asteroid impact for this one here that starts out wider and pinches out to nothing. And there's one in here, it's a little hard to see, but it's controlled by the Mid-Continent Rift structure, which is another refold structure. It's a little subdivision, just like the one on the East Coast. It's another subdivision. It has like particularly long legs, but it's still that classic C shape, and it's a refold structure. So what happened was the asteroid came. You see these white arrows here, right there, and shown on the fractals, there's 2 fractals here. So the white arrow would be here. Here's one fractal, here's another. So like a freight train, the momentum from the asteroid impact came above to the north of the Mid-Continent Rift structure and rotated it in phases. So there's this Grenville front here on the right side and the east side, and you can see it here, it says Grenville front. So it's like a resistant front and all. And what happened was, like a freight train came by and it twisted the MCR structure, the momentum from the asteroid. See that counterclockwise, of course, everything counterclockwise. That rotation twisted everything in a rotation there, and it tripped over that front. There's actually a piece here that's shown. It's crazy stuff. Anyway, so that gave part of the form and all of the MCR structure. And the gold deposits are associated with the structure itself. They're trapped in a zone here or whatever, directly related to the structure. And this one is related to the asteroid impact itself. So it pinches out to nothing. Again, we're only seeing the United States here. That's why it's cut off over there. There's like tons of deposits up into the north. And then it pinches out. So there's a reason for that, because that momentum dissipates and it disappears into the ground. So that there's evidence there that the asteroid impact is directly associated with these gold deposits. Okay? So they're structurally controlled, and they have to do with the asteroid directly. All right? So there's consistency again with the existing model, and very specific things like this Grenville front, and it's just all related. Okay, here's a real busy figure, but very important. So it's just a little more detail than the last one. You can see that gold deposit structure pinch out. It's got some drag to it, so I put in the word drag here. See, there's a slight concave to the east. Okay, it's just more evidence that it's accurate, because you see that there's that drag there. See where I'm circling? It's, the dial gauge thing. There's that rotation counterclockwise, and it's got a little drag component. Of course, the shearing component comes to a point. So, and the signature of rotation within the mid-continent rift, butting up against the resistant Grenville front. It all adds up. That's directly related to the asteroid. Okay. So it's all about rotation, rotation, rotation. The fractals verify actual conditions, such as the asteroid impact fractal. You can see here, there's another asteroid impact fractal there on the North America refold subdivision here. Right now it's stuck to Africa here and South America here. Africa and South America were the last to separate. That's what I was talking about. Everything was all together till that asteroid impact came and bent the axis, which is actually it was rotating about the rotational axis from east to west. Sun rises in the east. It's rotating from the from the west to the east. Actually, sun rising in the east. So this is the Southeast Asia refold structure subdivision that was above the Russia refold, which is here. Now it's separated. You have this an echelon fracture here, which adds up to with the whole dynamic. Now what happened was these arms of the Southeast Asia refold were attached to the inner Earth. Yes, this all sounds crazy, but they snapped out, and there's the signature for it snapping back from that sudden action of the asteroid impact, which is shown with the blue arrow here. So that's what it would do. It would bend the axis. It would pull the arms out, because that's kind of where it stabilized. This thing was like the captain of the ship, the Southeast Asia refold, during the first tectonic regime, where everything was rotating about the equatorial spin axis, and the system was trying to maintain itself about the equatorial spin axis before it was officially derailed. And then there's the modern tectonic regime, which is a little different. I'll explain that later. But anyway, there's the initial tectonic regime disrupted, and there's the signatures there of that happening. Okay, there we saw this before, the MCR, with that dynamic of the momentum of the freight train coming by and deforming the structure, and it rotating up against the Grenville front and all. So there's the location of and relative size of the MCR in the North America refold here. Okay, the Grenville front is in green, so it was like this, and eventually the North America refold structure rotated and folded over itself, as you saw, like it this one leg here rotated over the backside of this one. So that's why things look like they do now. And you can see if there's any counterclockwise rotation, this MCR mid-continent rift would butt up against the Grenville front, which is in green here. Okay, kind of jumping ahead, but anyway, this is the Grenville front in many areas of the world. Grenville fabric, I should say, is shown in green, and you can see sort of a signature here. Things are kind of oriented a certain way, whereas you can see where that second asteroid impact that I was talking about, that refolding event on another planet or whatever it was, maybe the sun. Anyway, boy, this sounds crazy, right? So that's where that refolding occurred. And that's why the signature is as such. See this, this is the perpendicular element of the Grenville associated fabric, and here's the long axis of the refolds. So here's the refolds here, these 7 subdivisions, 1, 2, 3, 4, 5, 6, 7. Southeast Asia ended up with its legs hooking into the middle of the earth. Okay, so basically this is all related. You can see a rotational theme that occurred, destabilizing the structure that was rotating to the east, from the west to the east, which is actually this way, west here to the east. The equatorial spin axis is right through the center here. All this rotated counterclockwise because the impact, which is right here, is just left of the center line. So that's why things started rotating counterclockwise. All right. So the first initial superstructure, Rodinia here, shown as sort of a football shape, but just to give you an idea what's going on, I put them together like that. This shows the fabric of the Grenville fabric there, and starting to see how everything's related. There's all those Rodinia fractals here going parallel, perpendicular to the ductile fault system here, which is coming to a point basically here. And there's the suture of the North America refold here in black. There's sort of a subsystem of fault system over here, but everything is going counterclockwise around the asteroid impact, which was over here. And the dial gauge thing came down like this and rotated that way. See that? All right, so there's this totally interrelated thing going on. All right, so it should be getting clearer now, hopefully. Okay, what we have here is Southeast United States, cluster of gold deposits. See my cursor over here? Okay, you can see it's tied into both phases, kind of. It just encompasses the whole area. And very tied in, by the way. You can see the border here of the red and the border there. All right, so interesting thing is here, is it almost looks like one of those Rodinia fractals here. You see the outline? Let me zoom in here. The outline of the subdivision of the gold deposit is outlined in red here. And it's strange because it has that same look with the 2 legs, the rear end, and the cone as the Rodinia fractals. And sure enough, it's going into and associated with a fault zone. Okay, so maybe that's coincidence. I don't know, but probably not. Probably legit. All right, so we'll go on to the next one. Okay, what we have here is I'm going to describe the another gold zone. See these deposits here in a thin lineation, so to speak, which are sure enough related to these faults, I guess, which are related to booted movement from the snapping between the around New Brunswick and what is now Alaska. That zone was connected and snapped, and there was a system of Boudins in here. Found tons of them, like I said. One example is shown here. There it is. There's probably one here, probably one here. Saw a bunch in another state. This could be one here. But anyway, definitely related to Boudins. They probably rotated from this end to that end because it's counterclockwise, and it ends up meeting up with where I think it snapped off over here. And now it's rebounding to the northeast or whatever. The yellow is connected. Yellow's the earlier phase, connects with the red. It's moving up into the northeast. Okay, so we have a connection again, consistency between structures and gold deposits, and everything's related to the asteroid impact. All right, what we have here is Central America. So you see Boudins in different phases here, okay? You have an earlier phase here, see where I'm circling, a red Boudin and a yellow Boudin stuck there for a while. That's why you see like a fossilized imprint, so to speak. And then they moved to where they are today, which is here for the red one, here for the yellow one. You can see like an actual dynamic where in the headwinds it got bent and all that, okay, because you're pushing up against it. That's what would happen when you're moving in that direction. Well, really from here, moving in this direction, it got bent here. And even here a little bit, there's a slight bending. Here there was definitely one. It got actually less bent as you move this way. So there's a whole dynamic you can see. You could actually see a superposition here. There's this bulldozing action where as the movement came from right to left, it bulldozed material here. So this came first. You can see the superposition here. This came first, this zone here, this bulldoze zone, from this, moving that way. And then this one from this moving this way, it bulldozed this. You see how it overprinted on that? So you can see these lines, and that one's there too. And then the North America refold here did this zone here. It bulldozed a little bit on top of this zone. Okay, and again, there's fractal support that you can see down here. Actually, what happened was, the mainstream geology will teach you that South America and Africa just separated straight across. But actually, it was a little more complicated as per these fractals and what I really believe, because it all adds up, that there was more of this what's called strike slip. It just pushed along like that. See how it kind of went this way? See the cursor? So it in the process, it ripped these boudins out, at least the action did. So you can see the yellow one on the right and the red one on the left. And there's lineations in this fractal that I drew in with arrows, but there's actual lineations there. So they flipped as such, and the yellow is going to end up on the left. The right is going to be the red. So sure enough, that's what happened here, and that's what happened here. See the for this phase, the yellow on the left, the red on the right. And now it's kind of lined up more, but the yellow is still on the left and the red on the right. Okay, so you can see that happening during this action, during this fractal, 105 to 110 million years ago. We saw the other end of this before when I was talking about, you saw the Russia refold on the back of the North America refold. This is that same fantastic fractal in Maine. So see the history here. I have a feeling that this snapped off earlier, but it just shows like a fossilized, so to speak, a phase in here. And the phase that's 105 million years ago is actually there. And then it got pushed along later. I think that's what you see here is more related to this right here. Okay, that phase where it got stuck there for a while. Because then that got dragged across the Caribbean. The Caribbean is over here. All right? So there's consistency again. It's all related to a rotational regime. Superposition can be seen. The order of events and all. Phases can be seen. Flow mechanics can be seen. The ductile behavior of the boudin here, showing the headwind of it, bending in that direction. And this one, headwind is bending, as it's bulldozing. It's bending here. It's still bent there, but less in today's phase. You can see the snap off the boudin pads and all that. This proving this counterclockwise rotational regime. It all relates to the current model of subduction in volcanoes in the Caribbean. So all that sort of remnants of what happened years ago, it's still active because there's, we're kind of in a time warp. So something that happened millions of years ago is still, we're still feeling the effects of it today because things have been moving through here and grinding and all that. And there's scraping and the whole thing. So, and again, the tremendous fractal support once again. And there's a whole rhyme and reason thing going on here, all related. All right, what we have here is South America refold. All right, refold structure, I should say. All right, so we saw this below inset on the lower right of the whole dynamic of those boudins in the outer fibers of the refold where the greatest tension is in the outside fibers. It's like a, kind of an engineering principle too. When there's rotation, you have the greatest tension on the outside fibers, so that's why the boudins are there. Now, you'll notice something. You're going to see a couple of different pathways. Some are the more inside here. See these orange, the orange pathway. So, and then you see the yellow and the red here. Later, that's got to be later because there's no outside fibers here. This is inside now, as shown. So at one time it was the outside fibers, and that kind of supports the fact that this is a refold. So what we're going to look at here, okay, this is published tomographic data, and similar to the North America refold, where you have the closed end here on the left and the open end on the right, and kind of the fabric is shown in these thin black lines. So again, incidentally, you have your oceanic plate that's dropping off and superheated here. Things are melting where this friction's going on. So where the slope increases or is more pulled by gravity, it starts dropping down where these yellow arrows are. All right, looks like there's a mini zone here where it falls off. See this yellow arrow? It falls off to where it says deep west slabs. There's a pathway there because it just drops off the structure there. There's nothing for it to stick to anymore. So this is probably an old oceanic plate that it rode over. Okay, it's more dense, the oceanic plate, so it went on top. The continent, the refold structure went on top of the oceanic plate, and now in a similar manner, it's dropping off and going deeper. Okay, this yellow arrow here says deep east slabs. It's probably something there that fell off, due to lack of support there on the underside, and material migrated in after the slab dropped is most likely. The green kind of represents that. So that came in after, sort of replaced that area where it dropped out, as shown by the yellow arrow. It dropped out. So very similar to what's going on what I talked about on the North America structure. Okay, so now what it's like an unfolding rebound structure because it's sort of, see this blue arrow here? This is a profile in red of sort of the action of it rebounding. So at one time, if you're standing on top, this is a profile, but if you're standing, see where the cursor is? The outside fibers, or really you'd be standing here, just say. The outside fiber is right here. Then today, it keeps rotating till today you're standing over here on the outside fiber. So where the orange is, the orange pathway, which now looks inside the refold, that was over here. So now as it rotates out and rebounds, you're standing over here and you get the yellow and red Boudin paths over here. So that's why there's proof here that it's kind of rebounding as such. Okay, see the red? That's the structure itself rebounding out like that. Rebounding out. Okay. Another thing to note here, this is published geologic literature of a magnetic anomaly. And there it is in the purple on the east coast of South America. So there's some kind of association here with the Boudin path, because what you see here where it was in the older orange path over here, it's mimicked because it's the same thing, just pulled out to the outer fibers over time on the right here with the yellow and red. So what happened was, if you take that the orange path right here, and you physically pull that right here, see the red arrow? If you pull it like that, you would end up with what you have later on here. See that? Just pull that along the line, and this is gonna, you see this orange shape here? That's now over here. See that? Everything was pulled. Okay, and those Boudins went goodbye, but they were one was here and one was here. Okay, so they fell out eventually because of this action here. They got pulled out. But you can see the mimicking here. This is exactly the same thing. The outer fibers here that you see in the yellow and the red, and the orange, this was just the earlier version of it. You can see that now. So there's this process again, and proof that there's in fact a refold that's shaped as it is, and that's rebounding, pulling out, and everything. Okay, so I just want to clarify. See this this figure, this geologic literature figure here. The blue and purple is a hotspot for a magnetic anomaly. Okay, and that's not so coincidentally right exactly where this red pulling is of the Boudin path in orange to the Boudin path in yellow. So there's something going on there, and it's possibly related to this dynamic here, how Africa separated from South America, and it kind of moved along. It looks like it's sticking right here. So there's some kind of attraction, most likely. That's all coming into play. Okay, so we just looked at some features, internal features and structures on Google Earth and within the North America structure and in Central America and all that. So now I'm just going to continue with how Google Earth reveals refold structures and microcontinents history. So it's all related. You'll see these microcontinents that are discussed in geologic literature, and I have things figured out from this model. Okay, what we have here is what I call the lost continent of continent A. I couldn't think of a name, so I just started with the alphabet, called it continent A. It's outlined in yellow. Shows a little bit of phases of this battle of pulling in this direction to the right, battling, and also a direction by these green arrows basically going down and causing this triple junction basically of tension. And you can actually see this crack. You can see a lineation in the ocean where this green line is. So there's that battle of tension going on, and this action of the arm growing from the pulling from the tension, this directed action to this direction, that pulled up the edge of South America refold here and the edge of Antarctica. So Antarctica was at one time together with Australia and also what became India. So India, as I described before, was like that arm that was attached. And that arm, which is over on this side, see the cursor? That was there at the same time that this is here. So, and Africa was closer, by the way. It was like right over here. So that's when this land bridge developed from between the two arms. A land bridge developed, and that caused, that formed the continent, microcontinent of Zealandia. And my model could explain why Zealandia, it looks like it does, and why it is where it is, based on the dynamic in this model, what happened in this rotational regime. And things are actually controlled by gravity, because these continents are, and microcontinents are basically moving for a reason. They're this merry-go-round system or whatever is controlled by gravity, because the land masses want to go where the access to the center of the Earth is, where there's more pull felt, because the crust or upper mantle is weak and broken up. That will be an access for the center of the Earth. So it's trying to find those zones, and there's a distinct zone you saw in one of the figures before, where the Africa arm is saving the system by pulling that Russia refold in. There's a thin upper mantle or crust over there that it's protecting, and everything's pulling into that. So even through the Mariana Trench, this continent here, this continent A, ended up going through the Mariana Trench and is no more. It's gone. All right. So this is all related. This microcontinent and continent A. It determined where that microcontinent of Zealandia was going and why. Okay, just want to clarify something here. I mentioned before that geologic literature plate boundaries are often they're like influence zones that could describe like a conglomerate of movements or whatever. Where the rock breaks on these plates doesn't necessarily match up perfectly with my model, but You can see why those plate boundaries are there often, and you check out any instance like right here, what I'll show you, you can see the relationship. Okay, so let's check it out. Remember that continent A came in here, the nose grew, and then it evacuated in this direction here. Did that K-turn, it went out on an angle like that. Okay, so let's check out the existing model and see how things are related. As usual, like I say, if you look at things, you can see why. Okay, so there's where the arm is. See this Scotian plate, it's called. All right, so that grew in there in this direction, and then it evacuated in this direction. See, from this to this. Okay, so what it's showing is green plate boundary here, and this teeth pointing to where the arm is, outlined in blue. So let's see what that means. Okay. Okay, so it says subduction zone here. It's a little blurry, but anyway, and the teeth are on the upthrown side, like the less dense side that's higher up, and the subducted material is below it. So it's also sinistral transformation, which is the green line, which means moving to the left from anywhere you look at it. As you're facing the arm, movement will be to the left from anywhere facing the arm. Okay, so let's see what this means. Go back to the drawing. Okay, so if I'm standing here and I'm looking over here, it says the movement is this way to my left, if I'm facing there, to my left. And if I'm over here, movement will be that way. Okay, so what actually happened, and it's saying that the material that went in the arm over here is the stuff that's on top, the less dense, and the stuff adjacent is really what got subducted. So okay, as this guy moved out in this direction, it's going to basically cause this this direction of, see, this is actually clockwise rotation here. So it came in, that kind of encompasses the coming in direction, and then the pulling out, especially if it goes in that direction. That's why you get your rotation as such, that interpretation as the sinistral or left plate movement here. That's the sinistral movement. So see how that makes sense? It's a little roundabout, but I mean, that's the end result is the overall composite of movement is going to be interpreted as such. Okay, I just want to clarify something again. So the upthrown side of a fault zone, where it has the teeth shown pointing to the upthrown side. So in this case, and actually in all the cases of where those teeth are shown on an upthrown side, that's where all the action is. So it's like a bulldozer going through. All the action of the bulldozer is on the upthrown side. So in this case, it would be the actual continent coming in and doing this action in here with the arm growing. That's the upthrown side right there. Okay, so that's pretty clear. And there's always a subducted side, and that would be adjacent here and here. Okay, so that's what's going on. That's what I'm talking about. Okay, what we have here is continent A shown in different positions in its journey. There's a reason for all these movements. Okay, so we just discussed on the previous slide this resting position here between South America and Antarctica. Incidentally, the border of Antarctica, the bottom of it, is still the same from this adjoining with continent A at this time. So it's still sitting there with that exact same shape. All right. So that battle was eventually won in this direction. See path 1 and 2. So it did, continent A did like a K-turn for a car. It backed up like this and then went the other way. All right. And this beautiful fractal in Maine shows what I was able to see was just about half of continent A, a little more than half. You can see it must have zipped out pretty quickly here from this blue arrow. It went quick enough, and this leg kicked up here. See the rotation. So the leg is down here, see EF, and then it goes up here from that motion. Okay, so it must have backed up a little bit more and then went forward with number 3 here, path number 3, to another resting position that you could actually see. Hawaii is over here, and then west of Hawaii is this outline you could see in the ocean that's, you can see divided up here that I showed with the different parts. And you'll see like what looks like a foot here, like a shoe or something in the green part of G. That is this arm here that flattened out in the headwind direction when it went that way. So see that it flattened out. Of course, the leg went back down here. See that? That's up here. Then it went back down here, E and F. All right. Between C1 and C2, I guess it's a soft, vulnerable area here that got pushed in and all. Earlier with C1 and C2, it just was a small divot, but over here it's pretty pronounced how much it went in. Okay. And see this section A here, this arcuate section A, that actually formed the shape of the Mariana Trench. What happened was this was resting here, eroding for a while, and eventually it got, I guess, light enough, or the forces were strong enough where it stayed in the brittle position. Well, it was once ductile, but it became brittle as it was uplifted and eroded. So at least the brittle section of it made the shape of the, it stayed the same shape and drifted right into what is now the Mariana Trench. And it, again, was formed by that section right here. Okay. So what do we see here? Basically, again, the continent A movement shown in phases. The flow mechanics are evident as I just described. The movement is consistent with this whole headwind and tailwind thing going on. Just talked about that. There's fractal support yet again, showing the intermediate phase. There's 2 phases seen for continent A. You can actually see in the ocean. One is fractal phase here, intermediate phase. There's several ductile arms seen. Well, one ductile arm for continent A, and it goes through different phases. But in the current plate tectonics model, they don't talk about any ductile arms or any ductile movements or anything. And if they did, they'd know that it would give indication of forces and all that pulling to make these arms, and it would give clues as to what happened. So I was able to do that with my model. I could show every single step. Okay. And again, even things are described, explained like Zealandia, which was between this arm here that I'm circling and what was ended up India over here. There was an arm that extended out. And Africa was right over here and South America was right here. So they were still adjoined. So there was a land bridge there, which became a microcontinent of Zealandia. As this quick evacuation occurred, as you see in the fractal, Zealandia rotated and got hooked and dragged along to its final resting position. So that is a geologic mystery that I can describe perfectly, and I did in another presentation. So you can see there's this great rhyme and reason with my model as opposed to plate tectonics that shows that there's just these random convection currents that drag continents along the convection current in very random directions at random times. So that's the difference between the 2 models. Okay, so we're still talking about what we see on Google Earth today is showing the history of the land masses, microcontinents, continents. So let's look here, and you see Australia. You see a section of Australia that looks like a Boudin, like there, right there in the green. So there's a reason it's in that direction, in that shape. You see the forces. This is chronological forces between 1 and 2. So there's a component this way and a component that way. So that makes sense. That's on that angle in a tensional zone. Okay. If you look at the Southeast Asia refold up here on top, let me zero in on that. You can see that it actually encroached on the vicinity here. See this yellow line? That's the edge of the refold that is Antarctica, what became India and Australia. Okay, so the edge of that, this encroached over it. So what happened was, and I'll get into this more later, Southeast Asia rotated clockwise. It's the only thing that rotated clockwise in this system. And I'll explain why, but you see it encroached on everything. And then recently, by the way, and right now, it's rotating counterclockwise. And that's why you have a signature that things are flattening out, but I'll get more into that later. Okay, so what we see here in Papua New Guinea, not sure if I pronounced that right, is an SC structure, and that is over here. So out of all things, it's moving with this shear direction where it's stronger on the right, making a counterclockwise shear sense. And the reason for that is because this continent A that you can see in the Pacific, that final resting position, that has moved into, it created that Mariana Trench with that shape there, that arcuate shape from this section right here. And because of that movement, you get that shear sense right here. See that red arrow? So here's just further evidence that there's a whole dynamic here, and it's all consistent and related. So, things are clear by the form of all these structures and land masses. For example, it's hard to tell right now, but even this little piece here, there's a reason for that. There's a reason for everything. This is where that arm developed. That was, see how this is there's a lengthening here, and then it's missing what became India. So there's this arm that developed up this way. And I was just talking about that's the other arm that connected a land bridge between this arm that was India. If you push this back, Australia, India was up here where the cursor is. So India was connected to that arm of continent A, making that Zealandia landmass, that land bridge. So everything's making sense. And it's, like I said, completely consistent and interrelated. You see that SC structure. Out of all things, it looks this way, which it should, in that direction. Okay. You see that history that I talked about of the Southeast Asia refold, which we'll get into more later. Okay. And the Australia Boudin, why is it shaped like that in that direction and all? That's explained. Okay. Mariana Trench shape, that's explained right there because that continent got pulled in over there. It's now gone. It's history. Okay. The breakup of one refold structure is explained here between the chronological numbering here, 1, 2, and 3. That's the order that these things happened. And what else? I talked about India over here. That arm got pulled into the large arm of Africa. Okay, so everything's making sense. It's all, like I said, it's all related to each other, and it's totally making sense. Okay, what we got here is the system of refolds and pieces of refolds that are trying to stabilize itself into this big attraction zone here. There's access to the center of the Earth in at least one zone. You can call it one big zone or two little zones or two smaller zones. See, those are outlined in the red there. I'll explain this in a bit. Ocean lineations, everything's coming in to that zone. So there's a, again, a rhyme and reason here. See that arm of Africa? It's, again, it's forming the boudinages there, and then it's curling up like that. See the two arms of the Russia refold outlined in yellow. They're curling up. You see the theme of rotation with North America in the distance here. And the arm of Alaska is stuck there on a plate boundary right on the arm of Africa there. There's a lineation there. And incidentally, they call this a subduction zone. See where the cursor is? It's not truly subduction. It's just an arm moving, causing localized compression. But it's not like a shrinking or a losing of you have extension. It doesn't equal out the compression areas. It's just localized compression because of these ductile movements below that are driving the system. So the Earth is expanding, and it's only localized compression in there in these subduction zones. Okay, so you see the Mariana Trench here. That's where continent A went through, formed that trench, and they see India there, like crushed up against the arm of Africa. There's these signatures here with the deformation and everything. You see the borders. So this is scientific signatures that are hard to make up or whatever. You see, it's this Southeast Asia refold is clinging up against the arm of Africa. Everything's getting crushed over there because it's, everything's really under stress here, under strain. Okay, and right now the Southeast Asia refold is rotating counterclockwise, which is actually a good thing. During most of the huge movements in the past, it was rotating clockwise, as this arm of Africa extended, it pulled the Southeast Asia in that direction with it. And see how it would rotate. If this, see my cursor, left to right, if that moved that way, that would pull that with it from left to right. Southeast Asia would rotate clockwise. That was most of the history. Very recently, it's rotating counterclockwise, and as you'll see on the next slide, I believe it is. But all this makes sense. It's all interrelated. This ocean lineation I described, it's called an extension zone here. It's not like the Mid-Atlantic Ridge, a spreading center, but it's an extension zone, and that's because this movement of the arm was along here, and the latest retraction was pulling back along it right here. So that's like a tearing or an extension thing going on there. So if you look at this, well, let's look at the fractal first of all. See that yellow outlined Russia refold? So there's a lot of pulling coming in. The arms are pulled in like that. And you see the arm of Africa with that curling with the white arrow. So now you go here, this little tiny guy right here, this refold in the fractal, where my cursor is, it's controlling everything. The arms of it itself want to pull in, see the blue arrows, and everything around it, even these gigantic refolds, they're too big to get in there. That's why they're curling up. They just can't make it. So the path of force is in blue and all that. So these other ones are trying to get in, but they can't make it. So they just kind of curl up along that path. Okay. And then if you look at this, this is that, I call it the hot spot of where the system is and where things are under like a temporary equilibrium here, this balancing act, I call it. There's the Russia refold here. There's the arm of Africa. There's the little arm of Africa crushed when it moved this in and stabilized it. This arm retracted back from about this area to here in more recent times. So this arm was formed over this area because it's protecting a broken crustal upper mantle zone here where things want to go in. So it's saying, hey, not so fast. We don't want to, the whole earth to destroy itself. So I'm going to protect it here. I'm going to heal the wound, so to speak, and go right over it. Okay. And there's still that attraction there. And there's another little one here. You can call it one big zone, but there's another one here because the Southeast Asia refold right here, the cursor is, that has an arm right here in magenta underneath. You can see from the character of this thing that, well, it's hard to tell here. You see it on another slide. It's rounded and everything. It's because it's going dunked under the water, going down into the center of the earth along this magenta line here. And the anchor, the suture, is at the equatorial spin axis. I'll explain why that is and all later. So here's the that old resting position of continent A, which is not there. The continent is gone. It went into the Mariana Trench. So you can see in this red elliptical zone, that's another zone of like broken crust, upper mantle, where things are attracted because they have access to the center of the earth down here. So this Mariana Trench did this. It was right where it was, and it finally went, caused the arcuate shape of the Mariana Trench here, went into or below the Southeast Asia refold, and is probably down there or trying to get down there now at the equatorial spin axis. This is Australia here. The head of it got pulled off, which is became India. So there is the there's India right there. I just showed the action with the arrows here. It's going into the arm of Africa. There's a slither of land left from this refold, which was Australia, this, and Antarctica and India. So that's all one refold. Show the arrows of action here. So there's India right there, showing the signatures of compression and all that. And this Southeast Asia refold pushing into it is probably a last phase here, smushing it up this way. So there's a reason for everything. Is this, well, when this rotated clockwise, was the destabilizing, that's when it really pushed up against that. Right now it's got a counterclockwise phase right now, luckily, because all the horrible things happened when it was rotating clockwise. That's when continent A went into what caused the Mariana Trench. It went into that zone. All right, so you're looking at things that make sense and are interrelated here. Okay, here's the Africa arm that is stuck there, and once it slides, there's going to be a huge geologic event that I think the authorities don't want you to know about. There's a plate boundary here and a subduction zone here, not a true subduction zone. Okay. So everything is interrelated, and system's protecting itself through this balancing act. As I said, there's a rhyme and reason, attraction to these different elliptical zones here for a reason. Okay. It's all in a rotational system. There's fractal support in this example. Yet again, so the Boudins are forming in the arm. You can see that arm of Africa. Lineations are there for a reason. It's apparent that the continents are or were broken up, and there were similar structures. They're basically all of the same relative size and relative shape. They all started out as basically crescent moon shapes, and you'll see that. So everything's related on different levels. There's a rhyme and reason, and everything's related. Okay, what we have here is the that hot area again, where things are reaching a temporary equilibrium. The center of action here, balancing act area. Just get a better view here of the Southeast Asia refold in particular, so you can see what I'm talking about. During the destabilizing part of history, when continents like Continent A went in here, and India went up into that area, that was when this was rotating clockwise, and it was rotating clockwise, the Southeast Asia refold, when this arm was moving out this way, left to right, and extending. Okay, so it stuck to it, so it got pulled with it from left to right here, and then rotated clockwise. And it, in the process, it deformed India, which was out here more, and then it smushed up like that. And also, as I said, this whole refold is now encroached on the area of, let's just call it the path of where India broke off of Australia. Okay, so see the red arrow there. So this did further encroachment from that clockwise rotation, went into the over that zone of action there. Okay, and then the latest phase is actually counterclockwise this way action, which is a good thing. So what happened was, during that time, this headwinds bent that as such when it was in the ductile state. So it bent it. It flattened that also. Okay, so there's a signature of later movement there. And the outer fibers of something, if the center of rotation is here, the outer fibers are more out here. That's why this is going to move faster, and it snapped. That's a left lateral fault. So from here, see the yellow, to here, moved in a left lateral fault direction. So that's more evidence that recent things are moving counterclockwise for Southeast Asia. And I guess that's a good thing, like I said, because when it was moving clockwise, you had all that movement, all those geologic events. All right. So I guess I got everything. One thing I should say is you can see the Southeast Asia refold is rounded here. And the reason for that is that it's dunking down and going towards the where it anchors down at the suture at the equatorial spin axis, which is over here. See the cursor? So that arm dunks down in this direction as such, and anchors down over here. And that was one of the red elliptical zones that you saw on the last slide. So there's like two hot zones. One is when the arm of Africa reached out and quickly retrieved the Russia refold. I guess it broke up the crust or whatever during that bulldozing process. So there's a weak spot that it covered up by actually stabilizing the system itself, this arm. So that's one little spot, big spot there. India's trying to get in, everything's pulling in, the Russia refold's arms are bending into that area. Then the other spot is where Continent A went, and see the cursor, it went in this direction, and I think it's probably going towards that anchor. See the cursor there, going towards that anchor at the equatorial spin axis. And even this one's related to that, because everything wants to go eventually to that equatorial spin axis where the suture is, where there's a weak spot. So everything's about gravity. It's trying to pull in to the center of the Earth, gravity controlled. Okay, so that's everything. Okay, so I misstated something that could be wrong. So that original movement of the large Africa arm was actually when the Southeast Asia refold rotated clockwise from that violent movement when Africa and South America, which was connected, when it moved with that I call the twerk movement. So the system derailed because it snapped between the Southeast Asia refold and the one adjacent to it, which is the continent A refold. So with that great movement, the Southeast Asia refold rotated clockwise, and the anchor, there's only one anchor at this point, and it's on the south arm of the Southeast Asia refold, anchoring to the equatorial spin axis. That must have busted up the crust and upper mantle area in that zone. So that was the first initial weak spot, and that's where the arm of Africa went to first. So it could have been worsened, and it's probably in the same general vicinity when the Africa arm reached out to retrieve the Russia refold that I described. But I think at least the primary movement and the driving movement was due to the twerking, I call it, of the Africa and adjoined South America refold when it did that movement and everything derailed. That made Southeast Asia go clockwise and really tore up that area. And that's why the arm formed and tried to get in there, cover that up. Okay, that last narrative about the twerking motion of Africa, how it forced the Southeast Asia refold to rotate clockwise and all that. You will see that in the upcoming slides. It's just something I wanted to set the record straight on because I didn't want to misstate anything, and for clarification later. Okay, what we have on this another busy diagram is we saw this before. This area, that's the hot spot and all. Just showing the rest of the refolds in the system. There's North America and South America here. That's the equatorial spin axis. Antarctica here. So the actions are shown by the arrows where things went, and then they join up on, there's the other equatorial spin axis, sort of a flip side of what you see over here because it encompasses all the refolds and shows the movements and all. There's the two ellipses. So what are those two ellipses? Those are like interpreted as, through geologic literature, as low gravity zones. They might call it one, but there's like a little localized stronger spot here, and there's the big one here. Okay, so that's the big one here, that's the littler one there. So exactly where they are here, I determined right here. So you know that this model is accurate because you can't solve a mystery like this. Why are these here exactly there? And there's two of them and everything. So the chances of me having these areas right here as key areas that are, I'm talking about like broken crust and broken upper mantle zones that are vulnerable to, access. Everything wants to access through there to get to the center of the Earth here. That wouldn't be the case unless I had a very accurate, good model. Okay, so that's what's going on here, and there's other mysteries solved. This is just one example. We talked about a lot of these insets, so I won't discuss that. We're going to talk about this one later. Okay. So, again, that balancing act there, you can see there's this rhyme and reason again. You can see the in the balancing act, the little arm of Africa crushed and the big arm of Africa balancing everything. You can see the strain going on again. And again, the fractal support for all of this. Okay. And geologic literature support. So everything matches, that there's agreement. And, it's the only way that this can be solved out of all places on the globe, here and here, and my model shows them here and here, which matches up, is that I'm onto something. And I solved this mystery among many. Okay, so we know this model is accurate. So you guys gotta wake up to everything, please. Pay attention to what's going on here. This is all the answers in here. Okay, what we have here is the microcontinent of Greater Adria outlined in red. See that here? Outlined in red. And you have the outline of the Africa refold with the arm over here. The outline of Africa refold in blue. And that arm, remember I was saying, got crushed and all by the Russia refold. When the system was trying to stabilize and it coddled the Russia refold, the arm retracted back a little bit and squished it in even more or whatever right here. So you can see like an oozing sort of signature here. You see the yellow arrows, everything's like crushed and oozing, so to speak, including the arm itself over here. It's you can see that crushing action in the signature. So what happened was when the Russia refold got to its final position, it's in the orange here, so the bottom of it is the orange outline here. It pushed the greater Adria refold out of the way and it split. See how there's a splitting here? There's like a top hat section here, where my cursor is on the left, that was up and over here. It fits in nicely. See that? See the cursor there and here. So you take that and push it on top and it fits perfectly. It was elliptical shaped more or less, greater Adria, and then it snapped along there and sheared off this way, okay, from that action. And then it's showing the oozing direction in that same kind of shearing direction. So when that top came off, sheared that way, as the blue arm got crushed, it sheared off the top section of greater Adria and put it where it is over here. Okay, so again, as part of the balancing act and effort to reach equilibrium, that's what happened, and it's yet another mystery solved. Why is greater Adria here, and why does it look like it does? So it's all from the crushing action, like I said, of the Russia refold that came in and pushed down the little arm, secured itself in there, pushed down the little arm of Africa, and in the process snapped the that greater Adria microcontinent, which is on the surface. It got dunked down and all as part of the action, but and you'll read about that in geologic literature, but basically it snapped off there, and there's the upper part that was fit in nicely before over here, and then it's displaced by this Russia refold. You can see the oozing ductile action here with the yellow arrows and with the arm itself up here. Okay. Incidentally, the Alps formed with this crushing action of the little arm. That's where the Alps are, the heart of the Alps, highest Alps and all, from that crushing action. Lots of deformation. And you can see these Budins here in Africa, and they're collecting up against the edge of the refold. They're formed in a rotational environment again, in the tensional outer fibers here of the refold. So everything makes sense. And geologic literature supports my model. Everything goes hand in hand. It's beautifully explained by my model. Okay. That I put in the outline of my model for the little arm of Africa and the coast of Africa where everything got squashed over here. And I put in the Russia refold. Everything makes sense. Okay. So there's this agreement with geologic literature. Again, even all the details and history of greater Adria are supported by my model, which I don't describe here. I should say that the microcontinents complicate and confuse tectonics, mapping, and interpretation, just because there's sort of an independent thing going on, like after the fact that the refold structures are there and they formed early, and then these microcontinents formed a lot of times from land bridges. In the example of Zealandia and even greater Adria is a land bridge that formed. So once it became a continent and hardened up into rock and all that, then things got moved around, and it sort of just complicates history. The more of these microcontinents that formed, and there's others, but this is an example of a mystery that's pretty much solved from my model. Okay, so now we're moving on to the specific tectonic history of the Earth. There's two different regimes. There's a Precambrian tectonic regime. I'll go over the explanation and driving mechanism. And there's a modern tectonic regime, which you saw, but I didn't explain, not carefully enough anyway. I'll go over the explanation and driving mechanism of that. So once again, the structures and fractals are vital. They support each tectonic regime framework, and they demonstrate ductile signatures, which can't be made up or imagined or all that. So it's the real deal. So I've only mentioned so far that there was an asteroid that hit in what is now Canada, and there's this rotational system regime that I described a lot. But you should just know that this refolding, these interference refold structures, which are the continents and the original large continent, supercontinent of Rodinia, that had to have formed in a huge, I've mentioned this, but it has to be formed in a huge area, like some other planet or the sun or something like that. It has to be something big, because now those structures are on Earth, and the relative sizes of all these structures, which are relatively the same size, are just too big for the Earth. So they obviously came from somewhere else. I know it's bizarre, but I'll get into that. I'll explain everything. Okay, first part, Earth's tectonic history, the Precambrian tectonic regime, explanation and driving mechanism. Okay, here we go again. Here's that textbook explanation here of interference refold formation. So according to geologic literature, there was an event, a tectonic event, about 2.5 billion years ago. Lots of folding. So I put that with the red arrow there. I believe that was an impact. That was when Columbia was assembled, as per geologic literature at that time, 2.5 billion years ago. So that's the first folding event on this large planet. Could be the sun. Sun's still on fire. Like I said, maybe that's the source of everything. Who knows? Eventually, 1.3 billion years ago, according to geologic literature and matching my model, Rodinia was assembled or formed from the refolding event. And I think that's another impact. These impacts are the only thing strong enough to do this kind of thing. Okay, so the end result, you have this plus this equals this, see on the right, and you get your Rodinia-shaped interference refold structures in yellow, and they subdivided into, again, principle of fractals. So if you have this refolding pattern on the interior of the supercontinent, you're going to get these subdivisions that later became the continents, and they're shown as the blue crescent moon-shaped structures here. So as you know, like Africa and South America are basically crescent moon-shaped, and they were attached at one time. So talked about this before. There's the profile. There's closed end and open end and all that. All right. So eventually these, maybe during the event or just after or whatever, they were ejected off, these structures in yellow. And of course could be in blue also. But the structures were ejected off of the large planet. And what happened to them? Well, this is where it gets really weird. But that is fractal in Nova Scotia, and I believe that is Rodinia, outlined in red here. See my cursor? Shows two different phases. Earlier phase without the arms going up is right here. The rotation is from left to right based on the structures here, which these are, it's called an echelon structures, and based on the shape of them, it's going from left to right. And based on the deformation of what I believe this is the moon, in yellow, in green, and it is rotating around the inner Earth, which is the inner and outer core of the Earth, shaped here in blue. So there's an attraction with the tip of Rodinia wanting to exit off the moon, which it does eventually, and deforms it in the process. And you see the signature here. If it's going from left to right in rotation, you're going to try to stabilize everything by having a longer arm on the right side. And you see when it goes up, it's longer. It used to fit as such. And that's what would happen if it was releasing in such a manner. You don't want to have that headwind direction protected with a longer arm on the one side. And eventually this Rodinia structure releases, and it goes to the inner Earth. Okay? Sounds bizarre, but there's evidence of that in these fractals, as you'll see here. There's the chronological sequence from 1 to 2 to 3 of that structure of Rodinia, the supercontinent, attaching to the inner Earth. It doesn't show it like that clearly, but it shows once it's there. And basically, it's showing that these structures shuffle around and everything to reach equilibrium. I won't get into the extreme detail here. You'd have to read the text and look into the drawings that I have on the cloud and all that to see what changes and why, but it all makes perfect sense as it goes from 1 to 2 to 3 to 4. Okay, so that's the Rodinia structure stabilizing itself on the inner Earth. So there's 7 structures. 1, see where my cursor is, North America, Africa, South America, the Antarctica, Australia, what became India, refold here. Continent A, which is that lost continent. And then you have Southeast Asia here. There's just a boundary shown in there, this is all Southeast Asia here. And you have Russia, and you have North America. Oh, that wraps around. So this is in Australia again, and what happens is these fractals, in these instances, they go in chronological order in a counterclockwise direction always with these fractals for whatever reason. So even the fractal order is in counterclockwise direction. So from sequence 1 to 2 to 3 to 4, it's not really shown here, but it does go in counterclockwise order. Okay. So the characteristics of the refolds are maintained today. You can see as this system tries to protect itself and shuffles around to stabilize itself, as finally it gets into position number 4 here on the upper right, everything's tied together. So it's working towards equilibrium, finds equilibrium, and again, the characteristics of the refolds are maintained today. Check it out. I mean, look at let's see. Look at Antarctica here. See where the cursor is? Antarctica still has that shape. If you look at Antarctica carefully, has like a hump like that. All right, and you'll see as further history continues that shape is maintained. It'll be more clear. And so the system formed like a sort of a locking mechanism on each pole. This is equatorial spin axis is in the middle here. It's going from this way to that way, from west to east, and the sun rises in the east. So when this Rodinia supercontinent collided with the inner Earth, it initiated the spin axis during that collision. And actually the Theia impact is what they called it. They know that there was an impact, but this is really what happened, I believe. And if you look at the geologic literature of the Theia impact, it's all feasible that this is exactly what happened, because this solves all the mysteries of the problems with the Theia impact theory. Okay. What else could I say? Did I say this is difficult to explain? My God. All right. So here we go. Still more. Looking at notes, going back and forth. Very difficult stuff to explain. So they form this locking mechanism on the poles to, when it's trying to reach equilibrium. See my cursor here, number 4. That's what it's eventually did. And the Southeast Asia refold here, the legs dug in, and each leg went towards the center of the Earth. Okay. And in the process, you can see as it's digging in, it actually bulges out the other refold structures. So it's impacting everything. And again, I won't get into the detail of all these phases, but it's really, really interesting. If you want to dig into it, you check out the drawings in my model. Okay. So I mentioned the spin axis initiation when Rodinia landed on the inner Earth. Okay. At this time, there was no mantle, I believe, on the Earth itself. It was just the inner core and outer core, and Rodinia structure attached to it. Okay. Yeah, the Earth was apparently smaller, and the mantle formed later. Okay. So the inner Earth, according to the geologic literature, is 1.0 to 1.3 billion years old, and the mantle, they say, is 4.5 billion years old, which is kind of strange because it's on the outside of the inner Earth, and 4.5 billion years old. I know the elements in the mantle are 4.5 billion years old, but it actually formed after 1.3 billion, after 1 to 1.3 billion years. Okay. So again, you're seeing evidence of everything I claim here in these fractals. There's this rhyme and reason. It sounds crazy. Please get out of the herd mentality. Have an open mind. Think about it. Really dig into this if you want to see I'm right. There's just no freaking way that I'm making this up or seeing things, because it all makes perfect sense. Okay? Thanks for hanging in there. Okay, I know this is busy looking here. Lots of words. So basically, I'm going to try to get through this. I talked about this. This is Rodinia, a fractal in Nova Scotia, when it's releasing the moon, and moon's in orbit around the inner Earth. Obviously, the moon is still in orbit around the Earth today. So eventually, Rodinia, as we saw in the previous slide, it attached to the inner Earth and stabilized at the poles. It caused formed like a locking mechanism on each pole, in the North and South Pole, and spinning due to the impact of the Rodinia superstructure onto the inner Earth. It caused that spin axis to go from what we see as east to west today. All right. So now this is between 670 and 550 million years ago, this fractal. Actually, the impact occurred 750 to 800 million years ago. And there's a fractal of the impact on North America, which is now Canada. See the direction that it hit. Equatorial spin axis is shown in green. That's the original equatorial spin axis. So that impact pulled everything to the left. You see that axis bent and everything that's shown in blue. This is the Southeast Asia refold right here. The arms got pulled out and snapped in. And there's another signature that's supported by en echelon structures. Again, en echelon fractures, I call it. So that would describe the dynamic perfectly. And now everything's going to try to maintain equilibrium about the equatorial spin axis, both laterally and longitudinally. Laterally would be this way, which is actually north and south. If this is the east-west equatorial spin axis. And longitudinally along the axis this way. So before I forget, there's something here. There's the next phase of North America. You see a lot of North America fractals because this Nova Scotia is in North America, and that's where all the action was with the asteroid impact. So this is a later shown in the model, this fractal here. So remember I was saying everything goes in counterclockwise direction between fractal sequences in chronological order. So this is older than that. That happens later, counterclockwise. We're going between. So anyway, so there we have this this tension that's developed, longitudinal tension developed from that bending of the axis, okay? And it's going to try to reach equilibrium, so the it does come back. Now what happens is the Southeast Asia refold here, it's still dug in on the one side, but the one arm came out and pulled back the Russia refold right here. It's showing, the subdivisions are shown in it, but this is all the Russia refold right here. And the anchor on the one arm of Southeast Asia still goes to the equatorial spin axis. It's still there today, and the same anchor is still there today right there on the equatorial spin axis. So it brought back, the stabilizer system brought back Russia refold there. It's still stuck to the North America refold here. And there's that, there's a cycle here, this longitudinal along the axis. There's the tension, things are split. See the space here and everything, things are split longitudinally and rotated that way. And then there's compression and then tension again. There's, see, compression, tension, compression, tension, compression. So there's this oscillation longitudinally and laterally, which I'll describe laterally now. So this disruption was taken care of by, first the arms were pulled out of the Southeast Asia refold, then one of them pulled the Russia refold back, pulled the whole chain back as such. Okay, so everything's trying to stabilize. Then, as you can see from the character of these refolds, there's this lateral oscillation. So when this comes back to the equatorial spin axis, momentum's going this way. To the south it is, because this is east-west equatorial spin axis. Did I explain this is difficult to explain again? Wow. Okay, but if you look at these signatures and you really dig into this, you can see what I'm talking about. So everything's going this way, and basically there's like these little subdivisions of where the axis is trying to maintain equilibrium. So there's like a temporary thing that it wants to maintain along the yellow equatorial spin axis here. It's not really the equatorial spin axis. It's like a, see how I drew the yellow from here, keeps going down, and it goes through the center here, and the center there. This is continent A. This is Antarctica, Australia, India refold right here. So there's this line in yellow that goes along the center line. So it says, hey, Africa and South America, come on, get back to this line at least, kind of stay up caught up with everybody here along there. So Africa and South America does like a twerk to try to get to that yellow line. Doesn't know its own strength, and everything gets shot further over here laterally. So there's those two refolds got shot over there further. And again, everything comes right back to where the anchor is, right here. This is the Southeast Asia refold here. It's anchored over there. So these cycles are shown as you go from west to east in sequence, and the time sequence goes this way from east to west. But did I explain this is hard to explain again? Okay. So anyway, this yellow line continues here. And actually, this is where it derails because the system derails here. So this twerk of the Africa and South America still attached. Remember, it was the last two unattached. This refold here, you can call it one, I guess, because it hasn't split up yet. So in that, I said it didn't know its own strength, that everything went flying. That actually derailed the whole chain by doing that. So it's no longer attached. And you'll see what happens. That'll be the second phase, the second regime of tectonics. So for now, just know that it derailed and it caused like crustal damage here because there's an anchor here to the center of the Earth at the equatorial spin axis. And that caused some damage because it went quickly. See the yellow arrow? So it caused like some, actually the damage is in here. If that arm attaches here, it was up here, that arm, and now it went down because of the yellow arrow. So there's like damage now to the crust and upper mantle there. And meanwhile, things are oscillating laterally, left and right. So you got everything to the right here, then it wants to go back there to the left, and the signature's there that the headwinds affected things here, so you know it's going to the left, and it wants to go back to the right as it oscillates. And there's this final compression stage here. God, is this difficult. Okay, so now it's derailed officially. And what's going to happen is, remember that there's a weak spot here because this went so quickly, and the arm here that attaches to the inner Earth was, it ripped up the upper mantle and crust area in this vicinity. So now there's a weak spot that determines the second tectonic regime, the modern tectonic regime, when this system is derailed from the equatorial spin axis, and the refolds are now independent, and they find those weak spots, and they want to access those weak spots as they move in great distances laterally off the equatorial spin axis. Okay? Holy moly. Hard to follow, but dig into it if you really want to, and completely makes sense. I described this on other presentations too, I think much better than now, because this is supposed to be a general thing that describes the weakness of tectonics, but it's got to be explained, I guess, while I'm on it, as good as I can. All right, so in summary again, those 7 refolds, they broke up from the asteroid impact. That's the driving mechanism of this first tectonic regime. See the asteroid impact fractal in here. So that's where it all started. See that right there? Okay, that caused everything. So system's trying to maintain equilibrium about the equatorial spin axis. So those cycles actually form the supercontinents, the early supercontinents, as they got together and everything. They formed supercontinents according to geologic literature. There's different ones that are described in the literature. And again, the characteristics of the refold remain today. Look at Antarctica. Check that out. That's exactly what it looks like today. Oh, now it's like broken off here, but that's, see that signature there? This is what is now Australia here. And eventually an arm formed that became India. But the Australia zone is in here. There's Antarctica. So you can see some characteristics remained. Okay. Let's see. So again, it's trying to maintain equilibrium about the equatorial spin axis laterally and longitudinally with these oscillations. Okay. Longitudinally along the equatorial spin axis and laterally north and south about the equatorial spin axis. Again, the supercontinent cycles existed, events, etc., all explained by my model, and the model can explain all major geologic events. Okay, you'll see that in the next slides. The Africa twerk, so to speak, caused Southeast Asia refold to bust up the mantle. Like I said, I'm just recapping. That's this area here. So that caused the weak spot here. That's going to drive what's happening after this. So you go from about 670 million years ago up here down to about 550 million years ago down here. That was the end of this tectonic regime, and now things are going to be independently moving. And actually, not so coincidentally, maybe that's when life started on Earth. Okay? And if there's any older fossils, the weird thing is they came from elsewhere. But the life boom on Earth came in the Cambrian about 550 million years ago, just after this tectonic regime ended. Okay? All right. Thanks for hanging in. Okay, so now Earth's tectonic history. We're going to talk about the modern tectonic regime, the explanation and driving mechanism. Okay, so if we review the last bit of the previous tectonic regime, or the beginning of this one when things are officially derailed from that bonding to the equatorial spin axis as a chain, now the elements are independent. So the last phase here, see that last cycle of compression longitudinally, and everything is starting to move now to the right. It had just moved to the left. You can see the signature there with the headwinds and all of the tails. So now it's going to move to the right to try to get back to, well, it's really just swinging to the right now. It's going to overswing. So, because there's no bonding now to the equatorial spin axis, the only place that it's bonded is at that suture attachment over here. Okay, and remember that arm to the suture, the only one arm at this point, this one's now free over here off the Southeast Asia refold. That's Southeast Asia refold. So this one that came in there to the equatorial spin axis has now caused like a weak spot in here because it went like that during this motion with the yellow arrow from that twerk as I described it above. So that big yellow arrow just ripped this thing from here, see the cursor, to where it is here. So in the process, that arm just ripped the area in here, so there's a weak spot. So just remember that. That's going to attract the refolds there. So it's going to start, everything's going to start swinging to the right now, just because the momentum's going that way. You have the last motion was to the left laterally, now it's going to go to the south or to the right. Okay? Keep that in mind. So now the system is rotating in a counterclockwise direction, and it's there's an arm developing to Africa. See this arm? That's going to try to find that weak spot, and it's already at 430 million years ago. This cycle started like 550, 540. So just prior to 410 million years ago, which is because I'm featuring 410 here. This is when like more important things happen. I'm showing. So that arm of Africa is developing, and it's going to search for that weak spot. So that's why it's developing. It's going to try to heal the womb, so to speak. This is right here, continent. No, this is actually what became India right here. See where the cursor is. So that arm is developing right there. And again, the system is now rotating to the right, to the south, and the system is counterclockwise. Okay, so you'll see North America is now rotating about its back there. You know, it was down like this against Africa. See the cursor? Now it's going up and allowing for this arm to build from Africa, trying to find that weak spot. So here we go. I won't get into super details, but you should just know that these arms are forming. The arms are the key to everything. Africa and what became India. Okay, things are going to start to move out. See, this was 410. Now 330. What I did, I put in all the geologic events according to literature, and they all match my model perfectly. My model can explain why these events happened. All right. So now there's a big jump. Check this out here between these two, between this one up here and this one. This is actually continent A now right here. The nose is forming, and there's this attraction there to that zone in there. Everything's attracted to that. See the arrows? Things want to go laterally because it wants to get in that way. It can't do it this way, so it's can't do it this way, I'll put it that way. It has to open up laterally to get in there. Okay, so things are swinging to the right anyway. And you see these arms developing between, this is getting bigger now, the Africa arm. There's more rotation with the Southeast Asia refold. Systems rotating like a merry-go-round, I called it, counterclockwise direction. Got this nose developing, this arm developing, that arm developing. This was the one that was India. See how it moved out? Moved out greatly. Okay. That could explain a lot of these geologic events, of course. So everything continues down to 200 million years ago. And this is just prior to like a big movement, the breakup of Pangaea. So that's why I stopped this here. Okay. Refold structures are now independent. They're moving as units, trying to find those weak spots because they're able to now that chain has been broken. There's no more binding to adherence to that equatorial spin axis. It is now just the Southeast Asia refold only on the one arm is attached to it. That's the only link left. Okay, so this is a new tectonic regime. So the system again is moving counterclockwise. Africa arm, India arm, continent A arm formed. Little arm of Africa too, forgot to mention that. That's forming here. There's that little arm of Africa. And Greater Adria and all is forming land bridge. Okay. So I wrote, geologic events align greatly with the current model. So all these text boxes, again, you can check into that on your own time or whatever, and it's all consistent. So I know I'm on the right track. The model's quite valid. Okay, this is model comparison, my model, which is on the right. About 200 million years ago, just prior to the major breakup of Pangaea. And there's a literature diagram of Pangaea. Both C-shaped and everything. And if you angle it right, it's even more accurate here. So this one is, see that shape, that classic C shape here. So there's a lot of similarities. The only thing that's missing here on the geologic model is there's no continent A. There's my continent A right here. And, lots of similarities. Check it out. Oh, well, a major difference is that everything is like a bunch of brittle puzzle pieces here on the geologic model, and mine is driven by these ductile refold structures below. So, land masses, they're going to fill in gaps and all with land bridges and all that between land masses. So basically you had even more similarity than what's shown, like the gaps filled in with land. So there's almost perfect alignment here with the refinement of the addition of continent A refold and the arms. There's no arms on the brittle published model here on the left. Okay, so the shape is identical. Again, continent A is the only difference. Ductile features such as the arms and bending and things are, see, there's like a bending features and ductile features on my model. The Boudins are here that came out of South America. All right, looks like things are ready to like really break up because North America is going to come rotating this way. Okay, so I mentioned that land bridges are forming like here, like Zealandia land bridge right here. Greater Adria is forming in there in the gaps. Okay, so the geologic events greatly align during this time, before it, and after. So there's evidence that my model is very strong. Okay, one thing that I should mention is all the arms that you see in my model that are missing in the existing geologic model, these arms are all formed on the open end of the refold structure. So I discussed that there's always a closed end. On this side is the closed end side of all these refold structures. Okay, and then there's the open end on the other side. That's where these arms are able to form because it's open. So there's a migration of material is allowed. Okay, just just to further show the strength of my model, the consistency. Okay, this is after the breakup of Pangaea about 100 million years ago. It's a figure that I made, and you can see just before the figure, this fractal, this famous fractal again, Russia refold's about to fall off the back of North America as things are rotating this way, counterclockwise. Once it falls off the back, this arm of Africa reaches out and gets it. Okay, so a lot going on here. And as that arm of Africa reaches out, it's sticking to the Southeast Asia refold here. And remember, there's an arm of the Southeast Asia refold going this way to the equatorial spin axis. So as this goes this way, it's going to rotate this clockwise. And as it rotates clockwise, it's exposing those weak areas and actually damaging the crust in here and upper mantle. So it's easier for these refold structures to access it if it goes laterally. So that's what it does. Here's continent A. It actually did that K-turn. It came out and went that way because it's trying to get in there. And you got this arm of what is now India that's attracted to that area. Now there's really two areas because the arm of Africa, the big arm of Africa, went over the previously created weak spot in the crust and upper mantle, and it's like covering it. So you got one zone here, and you got a second one here where that arm was when it rotated clockwise. It started here and it went like that. So you got another zone in here that's damaged. So there's two zones, 1 and 2. Remember those two red ellipses on that one slide? So you got two zones basically. You could see that North America was here, and now it's rotated off here. Okay, and by all this happening, this is the official breakup of Pangaea. You got greater Buddhan movement off of and through the Caribbean here. Okay, you have what I'm showing is the movement of Zealandia, because that formed from the bridge between the nose of the arms of continent A when it was here and the arm of what became India. So it formed here, and then it was rotated and dragged to the final position here, which is oriented as such this way, right there. That's where Greater Adria would be. Okay, so a lot's going on here. I always show the diagram of just previous to what I'm featuring. So this is 200 million years ago to show the difference. Okay, and now there's the featured diagram. Okay, so you can see also the little arm, now that it has the space to develop, the little arm of Greater Adria, the little arm of Africa formed here, and Greater Adria is about to crush it when the Russia refold comes down and crushes it. So it's probably just beginning to collide with Europe 120 to 110 million years ago, according to geologic literature. So everything matches. Again, these text boxes show what's going on in geologic literature, or my own comments, but all the geologic literature comments, what happened, agree with my model. So it's showing the strength of the model is it's very legitimate at this point throughout the entire time. All right, just to highlight again, see if I covered everything. Systems moving counterclockwise and laterally, trying to get those to those gravity attraction zones. Continent A has been mobilized. Pangaea is breaking up. The arm of Africa catches the Russia refold. The little arm of Africa develops. Central America, Buddhans move across the in a counterclockwise direction across the Caribbean here. That's what I was talking about before. I showed the this fractal support again right here, that famous fractal in Maine. Okay, talked about Zealandia and Greater Adria. Greater Adria developed over here. It's going to get crushed when the Russia refold comes down and crushes the arm, and causes that balancing act that I discussed that we have today. Okay, so I should note that you look at this and you say, how could convection currents be the driving mechanism? According to the current model, they are, and they're random. So that's where things are really different between my model and the current model. I have a rhyme and reason to my model, and there's definitive order, and everything's for a reason, and things happen at a certain time and a certain location, and it all is interrelated. So that's showing that my model is quite valid. Okay, what we have here is about 55 million years ago, and It's a relatively stable time, actually. Reason for that is, well, once that arm of Africa brought the Russia refold back and it's starting to crush it, through that action, it's actually retracting a bit, which means going from this way to that way. See the cursor? So it's that arm's retracting a little bit, and because the Southeast Asia refold is sticking to it, it's also going to go this way. So it's going to cause a stabilizing counterclockwise rotation. Okay, and you can see the little arm of Africa starting to get crushed. Okay, so this one Greater Adria landmass, the brittle landmass is gonna it's gonna break and all because of this action, because it's in here. There's no room for it, so it gets like dunked and broken, so to speak. Okay, because the all these movements are controlled by the refold structures. A microcontinent is formed later and it's on the surface, so that's just going to get lost in the shuffle when these things do what they want to do to stabilize the system. So that's what happened here. Again, slight stabilization of the system due to overall anyway, due to this action, the retraction basically. Okay, and then the subsequent counterclockwise rotation of the Southeast Asia refold. Remember, previously it rotated clockwise this way, and it exposed the weak zone in here so that these things came out to try to get to it. Now they're stabilized, they're just hanging out there for a while. The geologic events, as usual, align greatly with the model. Okay, they're all described in the text boxes. Alps are forming here with this crushing of the arm. And the North America refold, actually the one important event that happened, I think it was closer to 100 million years ago, but between the time of the last figure and this one, or just after 100 million years ago, the arm of what is now Africa was attached at New Brunswick, and it snapped. So now it's shown as it is. Okay, but basically things are stabilized. This continent A is hanging out here for a while and sitting there eroding until the next phase of movement when this rotates clockwise again. Okay, here's Pangaea 35 million years ago or so. This is like another highly active time, because what happened was the process of this arm extending out this way, the Africa arm, it had to do that, I guess, to get a good grip on the Russia refold to crush it, do the crushing action. I see the little arm of Africa getting crushed more, and this is where Greater Adria was, and it snapped at this point. So in this process, so if you picture this coming this way, the Southeast Asia refold is stuck to it, so it's going to go that way also and cause a clockwise rotation. And in causing the clockwise rotation, probably pretty quickly, it'll damage more crust in that upper zone where the suture arm comes from here in this direction to the equatorial spin axis. So it either damaged it more or just kind of exposed the weak zone more. As it rotated this way, it exposed these things to be able to access it better. This continent A, which ended up going, see the red arrow, ended up going in that pathway just as such to the probably to the suture zone this way on a little slight curved path. And so that activated that, and it also activated what became India. This arm here snapped off, and then it smashed up in there. And of course we still see that today. And I think part of the reason that occurred also is the clockwise rotation as such, like this from here to here, it probably sucked it in. There's this pulling like that. So this is a lot closer than it appears. This is just a diagram that shows everything like unfolded, on like a piece of paper, but it's much closer. This is closer, and that's closer to this area. So it's enough to really activate everything. So that's what happened. You see this greater crushing. You see, again, the reactivation of the system, due to that Southeast Asia refold moving clockwise again. And again, the geologic events align greatly. They're shown in the boxes. The continent A formed the shape of the Mariana Trench. It went through at that point, and the India arm, again, it went slammed into the arm of Africa, and the Alps continued to form. That's that happened greatly during this period, during that crushing event. Okay, and if you look at this, you can see there's like that greater expansion going on. It's really a well-developed triple junction here: one arm, two arm, three arm. I discussed that earlier. So it's apparent that there's not convection currents driving the system, but it's these damaged crust areas in this regime in particular too. Okay, I'm not going to go over this in detail again, but the modern tectonic regime is relatively stable compared to how it's been, but there's still a lot going on. And reason for that is right now the Southeast Asia refold is rotating counterclockwise, and that's why the headwinds have caused this arm to bend here and flatten there. So I went through that before. It's just sort of proof of that little detail. Some proof of that is the following. So there's the Southeast Asia refold. If this guy is rotating counterclockwise now in this direction, from left to right counterclockwise, the geologic literature says that today Australia is moving to the north and rotating slightly clockwise. So it would make sense that if this is moving counterclockwise as such, it would kind of pull, in suction, it would like pull this Australia with it. It would go in a north direction towards it as it rotates that way, and it would pull it like this. See how the cursor from that way? That's a clockwise direction. It would follow it. Okay, so that's exactly what's going on. Just another example of the strength of the model. Okay, on every level, you've seen all the way through, and all these geologic events. If you look at the PDFs carefully, you'd see, if you're really into this stuff, you can see that every geologic event is confirmed by the model. Okay, a lot of mysteries are solved by the model. So I wish it would be checked out more and spread the word if you see this model, and hopefully I get some good news soon. Okay, here's something really interesting. So put on your seatbelt. Okay, Moon's tectonic history. Is this all a coincidence? I don't think so, and you'll see why. Okay, what we got here is something really interesting, and I believe it to be true. I don't think it's a coincidence. What you're looking at here is the moon on the left side here, and it's always the near side of the moon that we see. And they say that that side was much more geologically active than the far side, and the near side is shown as having a lot of these black lava spots, which indicates more tectonic activity. So if you were to draw a line around the zone of where these spots are, now I know it kind of fades out here, for example. You don't see too much black here, but you do right here. So I'm going to count that. I'm going to go around it. I drew that red line in, okay? And what I think that is the butt print, so to speak, of Rodinia when it was attached to the moon, as you can see here on the right. So the moon is the green structure, and Rodinia is the red structure that is on its way to this high energy event. All these fractals are high energy events. It's on its way to releasing the moon, which is in orbit around the Earth, around the inner Earth at this point. So it's going towards it now. It's releasing the moon, and showing it in two phases again. There's one phase of Rodinia here on the moon with it still, and then its arms are up at a later phase over here where the cursor is. So I think that that's what that is. And this is kind of how it would be seen. Like if you're looking from the inner Earth, you would see, just picture yourself down here where the cursor is, and you'd look up and you'd see the near side of the moon as we do today. And, size-wise, it all makes sense. If the Earth today is like a globe that's 12 inches or whatever, the inner Earth without the mantle The inner core and the outer core are 6.5 inches. And the moon diameter would be like 3.27 inches. Okay, just to give you an idea of the difference in sizes. And the South Asia butt print would be actually as shown, like this scale, exactly that. So it makes sense, even like relative size-wise. So I believe it's true. It's just further proof of my model, and this is really, really weird stuff, but I think this is what happened. And they say the moon has been last experienced volcanoes and magnetism as recently as 1 billion years ago. That's exactly like the end of when I said that this is like 900 million years ago here when it releases the moon. So, it's very close. Maybe the 1 billion in reality is 900 million. Maybe I'm off and 900 million should be a billion. But very coincidental that the lava spots and the activity is on the near side of the moon. So again, if you were down here on the Earth, you'd see that near side of the moon. Here, you'd see that butt print as is. Okay, relative sizes, check out, etc., etc. And so that could be like a butt print, so to speak, of the Southeast Asia refold. Sure looks like it. That's kind of the signature of the Southeast Asia refold right there. So it's pretty crazy, but I believe it's true. Okay, I need to clarify something. If you look at over here, there is like higher concentration of the lava flows on this part here. So you would think that there's some kind of greater pressure in this direction towards that left leg here. Okay, so if you look at this, again, I was saying that if you're an observer down here on the inner Earth and you're looking up, you see that butt print over here from this squashing of the moon. Yeah, this is weird. I'm kind of embarrassed talking about it. But anyway, if you look at this, there's more pressure to the left. So what's going on here? During the greatest time of stress, you had this, movement in this direction. Okay, this again, it's supported by these structures here in red. See these things? So there's this movement in that direction. Okay, and if there's movement in that direction, this arm over here of Rodinia is going to go up first and higher to kind of make it, sort of a nice event. So that's just what's going to happen if you visualize it, as opposed to the other way around. This arm is coming up on the left here. So there's going to be more pressure, so to speak, on this section in here. See where I'm highlighting? Because it's leaning that way. It's pressuring that part, that arm more. Okay, so that could be why it appears, based on me drawing this line here, it looks like there's more pressure in this vicinity than over here. Okay, so things make sense. It's just more proof that I believe this is what happened. All right, conclusions. 1. A massive asteroid impact in what is now Canada initiated tectonics. The impact was so powerful that deformation was ductile, and the impacts of that asteroid impact is still going on today. It's as though we're in a time warp. 2. The driving mechanism of the Precambrian tectonic regime is the chain system of refold's effort to reach lateral and longitudinal equilibrium about the equatorial spin axis after the Canadian impact. 3. The chain system of refolds derailed from the equatorial spin axis in the late Precambrian and continues its counterclockwise movement. However, the movement was now controlled by gravity suction toward brittle broken areas of the mantle or deep crust, low gravity zones, that resulted from previous high energy tectonic events. These broken zone access areas, low gravity zones leading to the inner Earth, are the driving mechanism of modern tectonics and finds the Earth performing a balancing act in Europe and Asia. 4. Structures and fractals found on Google Earth support the framework of both tectonic regimes and demonstrate ductile signatures. 5. The tectonic model solves many geologic mysteries, some with great precision. 6. The tectonic model is greatly supported by geologic literature and data. There's a lot of agreement. 7. The current tectonic model ignores ductile features found by visual inspection of Google Earth, and therefore the driving mechanism of convection currents has no rhyme or reason. My model has a great deal of rhyme and reason, and you could follow the reasoning every step of the way.